Let me see if it's going to let me go live. Well, it says we're live.
I'll tell you in a minute. Yes, we're live.
We are live. It's showtime. Excellent.
Well, I say we're live. It's showing me an ad, but it's now stopped showing me an ad.
All righty. Oh, see if I can get things rearranged here a little bit. How you doing today, Alan?
Oh, same old, same old.
Yeah, I haven't.
The weather is a little less pleasant than it has been.
Yeah, we had some thunderstorms and stuff this morning, but it's all calmed down now. So I got a nice afternoon out there. I'm just hoping that the lawn guy doesn't show up and run his lawnmower right outside the window. But if it happens, it happens. That's all right. I can turn the volume down a little bit. Yeah, I haven't been live in a few weeks, and I thought listening to some of the crap that was coming out of Try Thinking yesterday got me a little irritated. I figured, why not? Let's just see if we can go live for a little while and straighten out some of the mess he made, if that's even possible. I'm not sure how you're going to be able to see this, Alan.
I was going to say, can't you share it in Discord as well?
I'm going to... Let me look and see if I can do that.
Because that's what you usually do.
Yeah.
Oh yeah, suppose I better like the stream, hadn't I? What I remember. Well, while somebody is reminding us out there in the side chat.
What's that? So are you seeing...
I am seeing it in the pop it out, because it's always better to pop it out. Yes, I be seeing it.
Well, that ought to work then. This was that was Bev's it was Bev's stream from yesterday. And as usual, Bev doesn't have any content. He just uses everybody else's content, just like he'll be using this content. He doesn't make any of his own.
Yes.
So what he was doing was going over a video put out by Petey, which was basically an exchange between Paper and Charles about angles and angles to curves and things like that. And that's the first part of it. So I thought it might be fun just to go through here and see if we can straighten out some of Bill's nonsense. Let me start out by saying that only somebody that never took any math or geometry or trigonometry would come up with this idea that you can't have an angle to a curve. That's just nuts. By definition, it's the same as the angle to a tangent at a point on a curve. It's no difference. The gradient of the curve is exactly the same as the tangent at that point on the curve. And I've got some stuff I'm going to show in a few minutes, but let's see if we can get Bev up here and running his mouth.
Stuff works.
You hearing that, Alan?
Yes.
Okay.
So, this video is done by Petey. Petey194 is his name. YouTube channel. This is a video 3 weeks ago, and as you can see, it's got the flat earth tag, right? So it's now got a flat earth tag. My video doesn't. The video it's taken from, so it's clipped from a video that occurred here on this channel. This, and it says it's titled "Try Thinking and Flat Earth Math Discuss Angles." That's the title of this. It's got 525 views. It's going up. It's more and more. Do we need to see any? I will look at the comments afterwards. Right, so this is a video taken from this channel that states, "Try thinking and flat earth math discuss angles."
And exactly how is that any different than the shit you do every day, Bev? Exactly what would be the difference in what you do with all of my videos and what this guy's doing with yours? What are you so offended by?
Let's listen.
You could measure an angle to a curve all day.
Absolutely not.
Draw a tangent, measure your angle, erase the tangent. The angle hasn't changed.
It has. You
Relation
took
to
away
what?
half
I
the
think-
fucking angle.
So
Yeah.
if we have a right angle, it means that we can draw between two.
So who's talking?
Me.
Okay. But who's got labelled with it? So anybody
Try
listening
thinking.
to this, who do they think Try Thinking is? Right from the beginning. As they're doing this. I will carry on.
2 lines, quarter of a circle. Quadrant.
Right. The
So-
sector, a quarter of the circle would be a sector, like 1/4 of the pie. Yes.
Yes. So
Yes.
you can draw any circle. It doesn't matter what this radius would be.
Yes. Like the example I was giving earlier.
So while this conversation's going on with paper and flat earth math, talking about angles, he's got a picture on the screen, as you can see, GeoGebra, that's got a quarter of a circle. And he's just drawing lines on it,
Yes.
right,
but
as
this
he's
is not-
talking.
This is not right because he should draw a circle around the center.
Why? I don't understand that. Why should he draw the circle at any particular point on that grid? You can draw it anywhere you want to, paper. It doesn't make any difference. It's a quarter of a circle. Is that too hard for you?
Because we are talking about, let's say, vertical and horizontal, as depicted in this picture, this reference lines.
Yeah, you can see the graph.
So, yes, on this graph, he should draw a circle in the middle, not as the top of this section of a circle.
Oh,
But
jeez.
this is maybe his invention.
As
the-
Parallax has put in the chat, that this video has been posted to make fun of me.
Yeah, that's what it was.
Okay, so this video, Parallax says that this video has been posted to make fun of me, and it's a discussion that happened here on this channel, right, about angles. The purposes will become clear that everybody should be aware of within this arena. Misrepresentation. So as paper says, it's a discussion about an angle, measuring an angle. And you can see here, there are grid lines that are perpendicular. And these lines are 90 degrees from each other, all of them. They go round there. You know what a right angle looks like. And in this picture, he's drawn a quadrant of a circle. We'll keep going, keep playing it. It's 8 minutes of a conversation.
Earlier is where does the diameter, or with what angle does the diameter hit the circumference? It's by definition, it's 90 degrees.
The diameter hits the circumference. So where's the diameter of this?
The bottom, this half, this is only radius.
Well, I
So-
think he's saying this is the diameter here. This hits the circumference.
Where
here.
is the diameter? What
Is
the
what he's saying.
hell?
This point.
He's drawn a
Kind of,
quadrant,
okay.
He's
and
drawing it, right?
Yeah, you're a
And-
quadrant.
it comes from the center, but where is that? Holy crap.
You can't find the center of it, guys? Is that little dot right there? That'd be my guess.
Yeah. Of course, it being a quadrant, it doesn't exactly have a diameter yet. 'Cause,
No.
you know, it's not been drawn far enough around. But
Yeah, so
Yeah.
it doesn't really matter. I mean, you talk about the diameter, how the diameter hits, or how the radius hits, all the same.
exactly.
Yeah. A portion of an arc still has, a diameter, because a diameter and a radius are kind of like the same thing. That's like the difference between zenith and vertical angles.
Oh, they're kin to each other. I see Petey out in the chat. In fact, Petey, you want to come in Discord and join in with this?
Come on, Petey.
Yeah, just answer in the YouTube chat if you can.
Right, so that's what Petey's doing. Petey's doing this drawing, and Flat Earth Math is talking about it. So let's try and follow along with what they're saying.
No, no.
And that's
one
a
second.
straight
By
line hitting a curve.
definition. Show us the definition.
Well, all I'm saying is you go.
So I'll go back here.
Would be.
Yes. Like, but the example I was giving earlier is where does the diameter, or with what angle does the diameter hit the circumference? It's by definition, it's 90 degrees.
What angle does the diameter hit the circumference? And he says, by definition, it's 90 degrees. Listen to it again. This is Flat Earth Math, remember.
But the example I was giving earlier is where does the diameter, or with what angle does the diameter hit the circumference? It's by definition, it's 90 degrees.
Right, so he claims, by definition, it's 90 degrees. So, where's that definition?
I got an idea, Bev. If you wanted to, you could look at Euclid, Book 3, Proposition 16. That might give you a clue. How about that? Try that one out.
This is what
I cannot
Petey's
find-
trying to do. 90 degrees. You can see that these lines here are 90 degrees. Everybody knows that. All of this grid, all of these, all 90 degrees. They're perpendicular lines, straight lines, to make this 90 degrees. So this is Petey, and Parabolic says that he's put this video out to make fun of me. Okay, here we go.
No, no.
And
one
that's a
second.
straight
By
line hitting a curve.
definition. Show us the definition.
Well, all I'm saying is you have
No,
four of them. And
no. Show us the definition. You said by definition. Let's see it.
It has to be 90 because four.
See, it has to, right? So it's changed from by definition to now it has to be by assumption.
Euclid, Book 3, Proposition 16. Thank you very much, Bev.
Assumption.
Dogmatic
Or
model. That's
belief.
it. That's
Yeah.
all he's got. There is no definition of what he's talking about because angles at 90 degrees requires straight lines that are perpendicular to each other. You can't do it with a curve. That's what we're talking about. So Petey's made this video to make fun of me, while there's a guy called Flat Earth Mathematics saying that the definition of the diameter to the circumference is 90 degrees, which it definitely not. It does have to be. He's right? It has to be. But in reality, it is. It's just perpendicular, horizontal, vertical. Simple. Here we go.
What?
Carry on again.
4 of them add up to 360.
What did he say? I'm going to go back and listen to that again. See if I can do it.
You can't do it with a curve. That's what we're talking about. So Petey's made this video to make fun of me, while there's a guy called Flat Earth Mathematics saying that the definition of the diameter to the circumference is 90 degrees, which it's definitely not.
It's definitely not 90 degrees. Is that what he just said?
He definitely said that. But Blue, I thought their great Lord and Master Euclid defined the diameter as meeting the circumference at an angle of 9, or at an angle where the angles on both sides will be equal, and therefore would have to be, by definition, a right angle.
Let's listen to a little bit more of this, because Bev just got through saying it's not 90 degrees.
Does have to be. He's right? It has to be. But in reality, it is. It's just perpendicular, horizontal, vertical.
So perpendicular is not a right angle then, Bev. Is that what you're saying? That's what you just said. You said it's not 90 degrees. So it's not a right angle, but it is perpendicular. How did you get that? I don't understand that.
Simple.
In your world, maybe not
Carry on
mine.
again.
4 of them add up to 360, and the 4 angles are identical.
If you have a circle and diameter, so
Yeah,
one
circle and a diameter, but it's
Yeah.
90 degrees. Where the diameter hits the circumference of the circle, it's 90 degrees. Paper. Can you imagine zooming in? Right? I mean, it's kind of
Right, so you can see what he's done. This guy called Petey. He's put a line down here, and he's put a point here. Now, this angle that's being formed here is from this point to this point to this point, and he's moving this point. Right? And it's changing an angle. As he moves, it changes. Right? It's not 90 degrees. But it is changing in this drawing as he's doing it, right?
Yeah, obviously.
kind of a silly phrase, but you could do it using, any geometric software like what's that one? GeoGebra is a popular one. Okay.
Yeah, GeoGebra.
If you zoom in to where this curved line is hitting this straight line, and you zoom in and you keep zooming in, at some point,
I know,
it will appear to be two straight lines.
Yes. This is
okay.
Used,
it will be indistinguishable.
It
two
would
straight
be
lines. Immediately next to the vertex. That's the only thing that matters. That's why Nathan keeps going on about celestial.
No, it's not, man.
You can't do celestial navigation because
sorry,
you can't
but
measure
angle
to a curve
is between lines, not points.
That is and again, don't take my word for it, but that is a geometric fact. You can absolutely measure angles.
It's a geometric fact. He says. That's gaslighting.
Curves.
No.
It is not gaslighting.
No,
Look it up.
It's definitely gaslighting.
Oh my goodness.
Post it. Don't tell us to look for it. You post it right now.
Oh my goodness.
Post it.
Or show us method. How you measure using ruler changing angle all the time. How you measure angle.
Just draw tangents. That's not a problem. Just draw tangents.
That's a straight. Look. What's he talking about? Draw a tangent. This angle here is changing as he moves this, because the angle is between this point, and the point down at the bottom.
And by the way, Petey, if he would be honest, he should draw a line between that point which he is moving to this intersection point.
Well, you can see that because there's an angle there, right? That's what it means, isn't it?
What if we drew it this way, paper? How about we draw it like that? You realize that that is true. That angle will always be, if it subtends the diameter subtends a portion of the circle, that angle will always be 90 degrees, always. And it stays 90 degrees. All the way to the point where you don't have a line anymore. GeoGebra can't make a line out of it because the 2 points are coincident. But look what I found. It's still a 90-degree angle to that damn circle. Oh, goodness. If we go a little past it, it's 90 degrees again. Does the same thing on the other side. This is what you call a limit, fellows. In the limit, that angle is 90 degrees.
There is a straight line from this point to this point. That's what this angle is depicted.
Yes, but it doesn't. It is not about this curve. This angle is.
It's just moving it. It's moving that point around on a curve and measuring the angle, and that angle is constantly changing. It's never going to hit 90 degrees.
Yes, it will. What?
And as he's talking here, that's all he's doing. Petey is showing you a picture right now. What you have to watch out for is the fact that Petey's showing you a picture of something. But if you understand what it is, it's a changing angle because he's moving it.
Yeah. So he's not measuring this angle.
No, he's
This is not
constantly changing. He's measuring all of the angles as he keeps moving it.
Yeah. Infinite number of angles, different from, and none of them is 90 degree.
Okay. And so far in this discussion of try-thinking and flat earth math, how much has try-thinking been talking to flat earth math about this?
Mostly me, and of course.
Are you
also
try-thinking, paper?
What are you?
No, I am paper organist.
So this seems like a really bad title for the actual video that Petey's doing. So if, like Parabolic says, Petey's done this to make fun of me, then he's doing it dishonestly. He's not actually representing the thing, which if you're trying to make fun of somebody, you best make sure that the person that you're making fun of is the person that's actually doing it.
Yes, but I would say that he's not. Okay, maybe in his own eyes, Petey is making fun of me instead of you. But
it's got my name on it.
Yes, I know.
It's got my name first on the thing. Try thinking and flat earth math. Not flat earth math and some other people discuss angles. No. This is try thinking.
But for me, the fun part is that he's. I think that Petey is making fun of himself because he's showing in this picture how you cannot measure angle.
Yeah, I wish Bev would realize that Petey's not the one that said he was making fun of Bev. That's something that Bev got out of his Discord chat. So there seems to be a bit of misrepresentation going on the part of Bev. I don't quite understand that. Petey never said he was making fun of anybody.
But Blue, we all know that Bev is a Delta Lima Charlie.
Yeah.
To a curve. But Okay, if it is funny for him, then okay. It's strange for me. He's showing how you cannot measure angle.
He's showing how he misrepresents arguments, right? Because
Yes,
the
also.
simple argument is that I stated you can't measure an angle to a curve, which he's showing that he's not measuring an angle to a curve. He's measuring a different angle as he constantly moves the point, which is ridiculous. And he's not discussing angles with me, which is even more strange. Straight line.
Straight line.
Okay, then erase the tangent, but the angle's not going to change. And that's the whole point about the tiny protractor. If you zoom in, at some point, the curve will appear ruler straight. It'll be.
This is where you agree with him, Paper. The only 90-degree angle is between straight lines.
Yes, I agree.
The angle would.
That's just fundamentally wrong, Bev. That's absolutely wrong. There is no problem having a 90-degree angle to a curve. That's just part of the way things work. In fact, I'll show you something in a few minutes that will probably really upset you. You don't need that tangent. We can find the angle to the curve without ever constructing a tangent. And I'm going to let a young lady that did a YouTube video on it explain that to you.
Change
Yes,
the moment you deviate away from that straight line.
Yes,
not 90.
Yes, but he said that this line would appear. And I agreed. Yes, it would appear. This is appearance. This is what they do with this zooming. To have apparent, let's say, assimilation of two lines. Apparent, not real. They are still different, and Petey is showing that, and these numbers are changing. So it shows that they are not the same, and they cannot be the same. Only appear. So this is just only a visual trick, and I agree with flat Earth math. Yes, apparently it may be seemingly the same, but only visually, not in geometry, not in mathematics. Not in numbers. In numbers, it would be different till the point of intersection. Nothing changed. So I agree only on this visual part.
Okay. Well, since
in reality, it will be 90. It will become 90 degrees. It will absolutely become exactly 90 degrees. It's 90 degrees to the tangent line and 90 degrees to the curve at that point. The curve has a constant gradient. A constantly changing gradient. But at the point of tangency, the gradient of the line and the gradient of the curve are identical, Bev. You need to learn some math, buddy. I don't know what to tell you, but this is pitiful.
It's my name here that somebody thinks that I'm the one discussing with flat earth math, then I think it's okay for me to say that there would never be a 90 degree on the curve.
Yes, I state the same. He's talking about appearance, flat earth math. He's not talking about 90 degrees. He's talking about lines which appear to be the same.
Well, see, this is where I think we may differ, because a line is the shortest distance between 2 points, right? There doesn't ever need to be a line.
Petey in the chat says he's changed the title. So, what did you call it, Petey? Paper organist. Did you put his name in there, or that would be a good idea? And just shut Bev up.
like Petey's showing here. There is no line for his angle. Right? So when you say it could appear, Petey hasn't even got a line there for you to think that might appear. Right? It's not there. It's a line. It doesn't exist.
But flat Earth math is talking about this curve, that it is seemingly overlapping this this straight line. And this is what I agree with him. Yes, in the picture we can see that this line seemingly is starting to overlap this straight line, because this line has thickness in the picture, so visually it is starting to overlap. And this is what he means by apparently, or he is using this word apparent. This is just visual trick, nothing more. In geometry, nothing changes. There are two different lines. One is curved, the second is straight line.
Again,
and
paper. I don't want to cut you off, but the point of this show tonight is misrepresenting try thinking. And once again, right, you are not try thinking. That's me. So you stating your case, which is the one that is in the video, that's your case, right? That's not me. I'm not saying that what you say. That's what you say. Not.
You know, Bev has a habit of spending 3 to 5 hours a night misrepresenting me most of the time. But he gets all upset when he thinks somebody's misrepresenting him. Huh. Wonder how that works.
Me?
Yes.
I'm not discussing this with Thingy, and I'm not having to justify what you say, because I didn't say it.
Yes, I agree. Yes. So he's just
he's misrepresenting what the conversation that's going on. He's misrepresenting what you're saying. He's misrepresenting what I'm saying. Basically, Petey's got a video here that he's purposely made to make fun of somebody by misrepresenting everything and trying to back up a load of ridiculous people that go by the names of flat earth mathematics to measure an angle to a curve. It's getting fucking ridiculous, right? And this has been going on for 4 years. We've watched it go on constantly. People come in, people go in, people misunderstanding arguments, people stating all sorts of different things. Yeah, I know, Lamal. Look, he's not disproving anything, because what is there to disprove?
Have you noticed one thing about this? Up to this point, have you heard Petey say anything? I haven't seen Petey do anything other than put a geogebra drawing up on the screen. He's not said a word. What the hell is Bev talking about misrepresenting?
Pass.
Gee, Bev. I don't get it. What are you so butthurt about?
There is no argument that has been made, right, in this whole thing. The case was, we said you can't measure an angle to a curve, and flat earth mathematics said yes, you can. The angle between the circumference and the diameter is 90 degrees. He said that by definition, and we said, both of us said no, the graph is the 90 degrees, not the angle to the curve. And as you can see here, this one here says 89.70 whatever. So he's not at 90 degrees, and he's still going along this line. What's it got? He's got 60, 10, 20, 30, 40, 50, 60. So let's keep an eye on the numbers as he's going and as he's doing this to prove exactly what he's saying. We're not at 90 degrees.
Try to imagine that dot getting infinitesimally close to the center point, Bev. Try to imagine that, because that's how it works in calculus. That's how a limit works. The limit is 90 degrees.
Yes, but
Indistinguishable from ruler straight, and it
Okay,
will
but-
still have an angle.
But we are not talking about visuals. We are talking about geometry and
Well, yeah,
mathematics.
but geometry has a very sound theoretical base, and so when you're talking about an angle, the only thing that matters is what is happening right at the vertex. It does not matter.
See, now here is what he says. The only thing that matters is what happens right at the vertex. Well, the vertex is one of the points,
Yeah, and
the
has a
one right
line.
at the corner. So there is no angle there. You need.
The only thing that matters, Bev, is the slope, the gradient of that curve there at that, what you're calling the vertex. That's the only thing that makes any difference. I'm going to show you how that works here in a minute.
need 3 points. This one, the vertex, and the other one, in order to have the angle between. Flat Earth mathematics thinks the only thing that's important is right there at the vertex, where no angle can be measured.
Oh, but it can.
No angle in vertex. There is no literally is no angle.
Uh-huh.
So, because to the curve is just different angle at each point, but at the vertex there is no angle.
Well, that's where he's saying the 90 degrees is at the vertex, which is
This is called utter
ridiculous.
nonsense.
Yeah.
I'd like to
Well,
hear
whether-
comments from like a machinist.
Yeah, that would be fun. I want to get to a point where I show another video in a minute, but I'm going to let this go a little bit longer, and then we'll see.
Petey missed that one. Flat Earth mathematics saying that.
Matter what happens an inch
Oh, look at that. Godzilla. Thank you very much, Godzilla. He says, hi everyone.
away, a mile away, 3,000 miles away. It's only what happens right at the vertex, which is why in geometry you can zoom in and you're eventually going to find it's going to have a limit. It is going to stabilize at an angle.
See, at the vertex where there is no angle, it's going to stabilize. But as you can see, this angle's constantly changing.
Yeah.
Literally constantly changing. It's not going to stabilize anywhere.
So Petey is rather disproving flat Earth math here
Yeah.
by showing these numbers, and he's trying to depict what flat Earth math is saying, disproving it automatically. So for me, this is fun part, but for me, not for him. He's not.
Yeah, and Shadow Falcon in the chat wrote it down for you, Bev. Read that. If f of x is ax squared plus bx, that's the formula for a parabola. I know you wouldn't know that, but that's what that is. Then the slope at any point on that parabolic curve is the derivative of that, which is 2ax plus b. So now you know what the slope is at any point on a parabola. Got it? I'm going to show it to you in a minute.
Making fun, in fact, of you or of me, but he's making fun of flat Earth math, I think, and he doesn't realize that. This is fun part.
Yeah.
At a very
Okay,
specific
okay.
angle. Like
I
if you
said-
zoomed in where the diameter meets the circumference, that will be 90 degrees. Absolutely.
But
If you zoom in, it will be 90 degrees. Well, the axis of the graph are 90 degrees, you can see. And since this is the tangent point, the only place that this is ever going to be on this straight line is right here on the tangent point. And if this point here is right here on the tangent point, there is no angle to be measured.
Yes, and by the way, zooming is not method of measuring angles.
It's not a mathematical
let's sort
method
it out
at all. It's not a geometric thing. And like we say, even mathematically, geometrically, if you zoom in, the only point that this here will be on this actual grid line is here at the point of tangency, because that's where he's put his circle. He started his circle. And if you do put that there, no angle. It's just a point on the vertex. But it can't be a vertex. It stops being a vertex. Because it's only a vertex when it's part of an angle. There is no angle.
Oh, good
So
grief.
this line is is only reduced to a point lying on a vertical line. So there are not two lines. There is only one line. So no angle.
Okay.
But I understand that. But still, it means that at this tiny distance between vertex and your chosen point, it will not tell you what is going on farther.
Yes, that's
on the
correct.
curve. So
That's
you are
correct.
not,
That is absolutely
Yes.
correct.
So it means that if you have a curve, you have to assume that this angle will change.
No, the angle's not changing at all. The angle is only defined by what
Petey
happens.
is
The
showing
angle's
that it
not
is
changing,
changing.
and it's
And
constantly changing.
constantly
Of
changing.
all
Yeah,
of this
yeah.
video, the entirety of this video, the angle is changing. Whilst Flat Earth Mass says the angle's not changing.
So I have to to thank
Petey.
Petey, yes,
Yeah.
because he's just visualizing my argument. Thank you.
Yeah, you can see this angle here constantly changing. It is not 90 degrees, constantly changing. And what we at here, we're down to 0.5. So we're zooming in, GeoGebra. It's really zooming in.
Happens next.
Yeah, you guys are totally missing the point, Bev. Completely. I'm going to read something here from Clive Wells in the chat. And Clive said to let x of s be the unit circle where x equal 1 is where s is arc length. Then 2x dx ds equals 0. So the tangent dx ds at any point is orthogonal to the radial direction at that point. That's just fundamental, Bev. Anybody that actually took high school mathematics would understand this. What is wrong with you guys?
Next to the vertex.
So
And that that's again, that's a blind spot.
Wait
It
a
is
second.
definitely a
No.
blind spot.
It's not a
He's saying that it's a blind spot, the fact that you think that this angle would be constantly changing, like Petey's showing. But it
That's not the
seems to be a
point.
blind spot for flat earth mathematics. He thinks this angle isn't changing. He thinks it's a constant 90.
Yeah. Petey is showing that it is not. Blind spot. This is inconsistency because you can have angle between any point on that curve.
I don't understand what you mean by an angle between any point.
Because from what you are saying, it means that you can have only angle between this tiny point near the vertex or whatever, but not further. And
Well, no. I didn't say that you can't have an angle further. I'm just saying it is not defined by what's happening further.
it is.
If you have two straight lines paper, then the angle's not going to change. You have a big protractor, small protractor, it's not going to change.
Yes.
But
so
if you
one
have a
angle.
curve meeting a straight line, then the only thing that defines that angle is what is happening right at the vertex.
See, again, he's talking about the only thing that defines the angle is what's happening right at the vertex. And if that's what you're talking about, there is no vertex. It's It's disappeared. It becomes part of the monad.
All right. I think it's time to show something else. I want to show this video by a young lady by the name of Heather Whitehead. Now let's see. I'm not sure that that's going to show, and I may have to reshare something here. Yeah.
I see it in the Discord.
You seen it okay?
Yeah.
All right. So this young lady is going to explain this to these idiots. Let's let her have a go at it.
In this video, I want to have a look at calculating the angle between two curves. So a little while ago, we had a look at calculating the angle between two straight lines, and we had this formula here. So if we wanted to find the acute angle between those two straight lines, and we called that angle alpha, then we'd know that tan alpha is equal to the absolute value of m1 minus m2 over 1 plus m1 m2, and m1 and m2 were the gradients of our two straight lines. So we're going to still use...
That's a trigonometric identity, and I can go through why that's true, but believe me, it is. It's easy enough to prove.
This method when we're talking about curves, but because curves gradients change the whole way along, there's going to be an extra step in there. So let's have a look at an example. So our example asks us to find the size of the acute angle between the curve y equals x squared and the line y equals 2x plus 3 at both points of intersection. So to step us into this, we're going to have one curve and we're going to keep one of our functions as a straight line. So we can read off straight from here that our, let's call it m2, is just 2. The gradient of that straight line is 2. But the problem with our curve is that it depends where we're looking on that curve, what the gradient's going to be at that point. So first off, we're going to find our points of intersection. So we're going to solve these two equations simultaneously. So let's call them equations 1 and equation 2. Let's substitute 1 into 2. So we're going to have, if we're substituting this x squared in where the y was, we'd have x squared equals 2x plus 3. Now we want to solve that for x. Let's bring everything over the left-hand side. So we're going to have x squared minus 2x minus 3 equals 0. We want to factorize that. You can use whatever method you like, whether it's PSF or cross method or whatever it is you prefer. And we're going to have plus 1 and minus 3. So that's going to give us our answers of x equals minus 1 or x equals positive 3. I don't need my positive there, I can just write 3. So they're the x coordinates of our points of intersection. I also want to find my y coordinates. So to find the y coordinates that relate to those x ones, we're going to substitute these x values back into either of those initial equations. It doesn't matter which one, you're going to get the same answer. So let's just pop it in here. Minus 1 squared would just give us 1, and 3 squared would give us 9. So that means our points of intersection are minus 1, 1, and 3, 9. Now to find the angles between our curves at those points, we need to know the gradient of this curve at that point. So to do that, we're going to find the gradient of the tangent at that point, which means we're going to have to differentiate. So if we've got y equals x squared, we know that y dash is going to equal 2x. So we can then substitute in our values. So at x equals minus 1, y dash is going to be 2 times minus 1, so minus 2. And at x equals 3, our y dash, our derivative, the gradient of the tangent, is going to be 2 times 3, which would give us 6. So this is our, let's change pen color, this is our m1 at this point, and this is our m1 at x equals 3. So we've got two different things we're going to find, two different angles. So we're going to have to use this formula twice now. I'm going to get rid of this. Oh, no, I won't. So let's go at x equals minus 1. Let's have a look there first. So x equals minus 1, we're going to have tan alpha is equal to the absolute value of m1, which was minus 2, minus m2. So m2 minus 2 minus 2 over 1 plus m1, which was minus 2, times m2, which was 2. So if we simplify down what's in there, That's going to give us -4 over -3. So the absolute value of -4 over -3, which just gives us 4 over 3. So to find our angle, we're going to go tan inverse of 4 over 3. And to the nearest minute, that's going to give us 53 degrees and 8 minutes. So at x equals -1, or at this point of intersection, at -1, 1, our acute angle between the curve and the straight line is 53 degrees and 8 minutes.
So she just found the angle between that curve, that parabola, and that straight line. In fact, we're going to measure it in a minute and see.
Now we also have to do that for our second point of intersection. So I'm just going to rub off this bit up here so we've got some space. All right, so at x equals 3, we're going to have tan alpha equals the absolute value of m1 minus m2, so 6 minus 2, over 1 plus 6 times 2. Simplifying that down, we'd have 4 over 13, and the absolute value of 4 over 13 is just 4 over 13. So alpha is going to equal tan inverse of 4 over 13, which is going to give us to the nearest minute, 17 degrees and 6 minutes. So this is the angle between our curve and our straight line at this point of intersection, and this is the angle between our curve and our straight line at this point of intersection. So I could have written my answer a little bit neater if I had a bit more room. But that's having a look at finding the angle between two curves.
Now, that's not all that hard, is it? Come on, guys. She found there's a reason she found two angles, and I'll show it to you in a second. In fact, let me see if I can get that up on the screen. These were the two curves. I don't know if you guys are seeing this in Discord, probably not. But you can look out on YouTube in a second. It'll pop up. These were the two functions she had. Y equals x squared. That is the parabola. And function G, was y equals 2x plus 3. That's the green straight line. And you see the straight line intersects the parabola at 2 points. That's why she had that. And those intersections are 3, 9 and -1, 1, just like she said. Now we can go to that sketch that I did on GeoGebra. And I plopped in the tangents at those intersections. At point A there and point O, or whatever I call it, whatever it's called up there, or D, whatever it is up there. So those dotted lines are the tangent lines, and measured those angles. And guess what? 53.1 is that 53 degrees and 8 minutes, and 17.1 is the 17 degrees and 6 minutes, rounded to 1/10 of a degree. So stop telling us that you can't find an angle to a curve. You sure as hell can. She didn't develop either one of these tangents. She just used the slope of the curve, the derivative of that curve function. Anybody unclear? Good. Let's go back to Bev again.
It's gone. Doesn't exist. We'll have a look at that again in a minute.
Doesn't involve curve anyway, because if we have this angle at this tiny point, just near the vertex, so if you want to keep the same angle, you have to prolong this line in straight. It cannot be curved because you will change the angle. So
like he's just
there
said.
is no, yeah.
The angle always stays the same in the straight lines, like the perpendiculars of the graph. And Petey's showing us that the angle constantly changes when you have a curve there. I mean, look how many decimal places he's got
You have no idea what he's showing, do you?
to an
Yeah,
angle.
so great job. So Petey did great job proving my point here.
And that means that's where you have the joke of the tiny protractor. Ha ha ha. But that is not really a joke, because the only thing that defines that angle is what is happening right at that vertex.
Again, he says the only thing that matters about the angle is what's happening right at the vertex. Well, there is no angle if you're at the vertex with your point. If you bring both of your points to the vertex, that's all you've got is a point. There's no angle to be measured.
Absolutely. So even it doesn't matter if this line is curved or straight, because there is no line here.
Yeah. Yeah, Petey's showing you that the angle constantly changes, and even when you're zooming in, what's he at now? 0.01 here.
Yeah,
0.02.
yes, we can see these
massive
red
scale
numbers
earlier.
changing.
Not inches away or feet away. In fact, it doesn't matter what happens inches away or feet away. The only thing that matters is at that vertex.
Yeah, and Rumpus is absolutely correct. The basic problem is Bev does not understand that a point on a curve has the property of a slope. You're right, Rumpus. That's exactly what it is. Bev can't fathom, these idiots cannot fathom the idea that that curve has a constantly changing gradient, a constantly changing slope. It's different at every point, but it is constant at a given point. At any given point, we know exactly what the slope is. No problem.
And in the
Okay,
example of
so-
a diameter meeting a
but-
circumference, it will be 90 degrees exactly.
I understand, but this you are talking about this very short straight line in between your vertex and this point of your choice, but still it is measured as straight line, because you are, as you said, that you are zooming in
Right, you
until
zoom into a
see
curve.
a straight line.
One.
So you are using a
Zero,
seemingly
zero,
straight line.
zero,
Anyway.
Yes.
one. We're at.
Yes, and it's
Okay.
it's indistinguishable from the tangent at that.
Yes,
another-
so,
Indistinguishable from the tangent, even though we're here at 0.001 and it's not 90 degrees. It's definitely distinguishable from this axis of the graph,
yes,
because
in
it's not
numbers.
90 degrees.
So notion again. I agreed again with him with this seemingly. I'm not agreeing with numbers and strict geometry, because he is using this word seemingly. Yes, seemingly, yes. Even on this graph, these lines seemingly are overlapping, but we know from geometry, because one of them is curve and one of them is straight line, they cannot be the same. Simple.
And can we just again point out, because this title of this is Try Thinking and Flat Earth Math, Discuss Angles. You're not try thinking, are you?
I'm not. I'm
Oh, good grief. Bev is just going to go on and on and on about that. I really want to ask him a question. Let's try the old trick. I want Bev. I want you to pick a wall out in your house, okay? And I want you to walk all the way to that wall, but I want you to do it by going halfway. Start by just going halfway, and then go halfway again, and then go halfway again, and again, and again. Can you ever get to the wall? Because it sounds to me like you don't believe you could. That point will become coincident eventually. It will, and when it does, that angle becomes 90 degrees. Exactly. That's the limit. Jeez.
paper organs.
So Petey has completely mislabeled this video.
And by the way, when flat Earth math was on Blue Marble Science and Rumpus interjected with his objections, flat Earth math said politely to Rumpus, you don't help, or it doesn't help what you say. So, Petey, I am saying now to you, it doesn't help flat Earth math. You didn't help him, really. You are just proving my point.
He did,
So
though.
What point was that? Did anybody understand what Paper's point is? I don't get it. I don't know how much more of this there is. Let's see.
He did.
He did, yeah. We'll get round to that.
It's almost done.
We've got to go to the comments to see the real effect of what's going on here. Right, this conversation obviously carries on here, and we talk about this, and you're discussing the actual technical terms of it, but that's not what this video.
So the tangent is serving no purpose. That's why I say the tangent is optional. You could draw it if you'd like, and it may be helpful if you had a physical plastic protractor. Then you may have to draw a tangent.
0.0.
I believe that's exactly what I just showed too, Charles. That's exactly what Heather did. You don't. She didn't have to draw the tangent. You can have it if you want to, but you don't need it.
AG1.
What did I just do?
Well, it just comes down to where he's all about, Euclid and shit, but he won't read all of the propositions. Anytime there's an arc or a circle in a Euclidean, proposition, he just turns the page.
Yeah. Yeah, book 3, proposition 16 talks all about it. That's where you get horn angles. So let's see. This goes, what he did after this was, he's essentially finished, so I'm not going to go through any more of the crap. What he did then was go meticulously through every comment that Petey had on his video. And it's the usual nonsense that you've come to expect out of Bev and Paper and the rest of them. Let's see, I want to get a little bit further over there, though. Let's see what he's doing around in here.
Really? We've only got flat Earth mathematics thing that he actually had a dinner, a romantic meal for two. Flat Earth mathematics and Jesse Kozlowski, the man that's never around, that won't come back.
Why should
the
he?
Only man with the method for measuring level diverting from horizontal.
Oh, Bev.
I think he said it went up. It rose up above it. But I mean, we don't know. Could have just moved to the side a bit. Probably. I mean, who knows? So there's only Jesse Kozlowski that said it. A lot of other people have said it, like Blue Marble Science has backed up Jesse Kozlowski because Jesse Kozlowski's the great shadow giant.
Now, wait a minute. Say that again.
Really? We've only got flat Earth mathematics thing that he actually had a dinner, a romantic meal for two. Flat Earth mathematics and Jesse Kozlowski, the man that's never around, that won't come back.
What is it with you guys and the constant homosexual references, Bev? What are you hiding something, buddy? I don't really care. I mean, you can put from the rough if you want to. It doesn't matter. It doesn't matter to me. But there's constantly something coming out of you or Mike Jones with some homosexual undertone to it. What the hell is that all about?
The only man with the method for measuring level diverting from horizontal. I think he said it went up. It rose up above it. But I mean, we don't know. Could have just moved to the side a bit. Probably. I mean, who knows? So there's only Jesse Kozlowski that said it.
Only Jesse Kozlowski that said it. Now listen.
A lot of people, other people have said it. Like Blue.
Only Jesse Kozlowski, but then a lot of other people. You need to make your mind up, Bev.
Marble Science has backed up Jesse Kozlowski because Jesse Kozlowski's the great shadow giant. But I mean, I'm guessing he's no longer around. Complete remake. He could even have put a dress on. We never know.
And yet another one. Excellent, Bev. High class.
Yes, as Jesse, the licensed professional surveyor, working at a survey office as like the chief land surveyor, yeah, he's completely gone away. He's probably drawn in the cool mid-90s, all right?
Yeah.
You never know what sort of a transformation can occur when somebody completely changes their internet character. It appears Jesse Kozlowski has said some really stupid shit, and then he knows that there is no possible way he can back up the things that he said. So, and I think all of these other guys, you know, the White Knights, for this, they know that. They know Jesse Kozlowski cannot come back and state his method for measuring this drop of the level from the horizontal, the measured drop of the level from horizontal.
You know what would be helpful is if Bev could ever come up with a citation that says anything even remotely resembling the claims he makes.
And you know, I kind of got to hand it to a FE Corps when they were screwing around with some sort of force the line, where they had rented a very expensive electronic leveling instrument, and they were scratching their head because they couldn't figure something out. And they said, "Oh, we left the curvature and refraction option turned on." And they admitted that. So, and in every electronic theodolite I've ever encountered that has an incorporated EDM, curvature and refraction options are in the setup menu. Why do you think they do that?
Don't know.
Follow the money.
I just want to show Bev what a citation looks like, and it's not a damn dictionary, Bev. Dictionaries don't make good citations. Something like this makes a pretty good citation. This is a book called Surveying Theory and Practice, written by Davis, Foote, and Kelly. This is my copy, my 5th edition copy from 1965. It's got lots of good stuff in it.
And it goes hand in hand with every other survey textbook. I mean, this is not an aberration. This is not like a one-off.
Definitions. The elevation of a point near the surface of the earth is its vertical distance above or below an arbitrarily assumed level or curved surface, every element of which is normal to the plumb line. That's a definition of level for you. Out of a surveying textbook, Bev, the definition of horizontal is this. A horizontal line is a line in surveying taken as straight, tangent to a level surface. Now, how do you think they have a horizontal line tangent to a level surface if the level surface isn't curved? Geez. Seems pretty obvious to me. And then, of course, there's this picture. I'll blow that up a little bit. Let's see if we've got a better one like that. Bev actually showed this the other day, and completely misunderstood what the hell it was telling him. This is where they're discussing the combined, as it says right there, the combined effect of the Earth's curvature and atmospheric refraction given by the expression. And this was hilarious. H prime is equal to 0.57 k squared, and then another equal sign, 0.21 m squared. Bev thought this was all one formula. He doesn't realize that all they're telling him is you can compute it using distance in miles or distance in thousands of feet. Jeez.
Yeah, punctuation matters, and there's an equal sign between those two things.
Yeah.
That matters. That means something.
It's not all one big equation, Bev. And there's the little sketch to go with it. You see the thing that says level line, see the nice curve to it? You see the thing that says horizontal line? That's a nice straight line. See the thing that says line of sight? That represents refraction. And then he bitched about why they had those things combined. And somebody, I don't remember which one of them it was now, was bitching because they didn't break out, how much refraction and how much curvature. Well, there it is. It's in that sentence right there. The effect of Earth curvature alone is 0.66 k squared. The effect of refraction alone is 0.09. Refraction takes away from curvature. Subtract 0.09 from 0.66, and what do you get? 0.57. Just like the equation shows. Same thing with distance in thousands of feet. 0.24 minus 0.003 is 0.021. Jeez,
Yeah,
guys.
just like in the classic 0.667 times miles squared.
Yep.
It's a piece of quadratic. Refraction is the same formula with a different coefficient. So it's 0.10 feet miles squared, but it's negative.
Yep.
Being quadratics, you can subtract them, and you end up with 0.57 miles squared. But adding and subtracting quadratics is a little above his level head.
Yeah.
The word quadratic, he hates that. He put a lot of disdain into, the quadratic god.
And one more thing out of the book I wanted to bring out was this, because we've heard this the same crap out of these guys time and time again, where they don't understand the idea of differential leveling. But just read the last sentence here, this last paragraph. Thus, if backsight and foresight distances are balanced, the difference in elevation between 2 points is equal to the difference between the rod readings taken to the 2 points, and no correction for curvature and refraction is necessary. That's why you do differential leveling. It takes out the problems of Earth curvature and refraction. Those things go away. You got the same amount of refraction and curvature at your foresight as you had at your backsight, as long as it's balanced.
I also like the quote in Davis and Foote under plane surveying 1.4, where it says the procedure ordinarily used in determining elevations automatically takes into account curvature in Earth, the curvature of the Earth, and the elevation returned to the curved surface our reference are secured without extra effort on part of the surveyor. In fact, it would be more difficult for him to refer elevations to a true plane than to the ellipsoidal spheroidal surface which has been chosen. So, yeah, they clearly distinguish a true plane from the spheroid, which elevations are referenced. And it's much easier to reference that spheroid than a plane because of the mechanics of instruments are oriented to gravity.
Yep. Absolutely. Well, I'll tell you what we'll do at this point, because I'm sick of listening to Bev. I'm going to move up to the general chat. Why don't you guys come up there? And anybody else that wants to join in the Discord can feel free to, and we'll just sit around and talk for a bit. How's that?
Sounds good.
And now we just got to get Larry to move up there. I can move him up there. Ah, he's there. Okay. And anybody else that wants to join in, feel free.
It's Bev's arrogance. He's just so ultra confident, and he's surrounded by technology that works. But he says that he just comes up with such disdain for it, as to saying all the levels are horizontal and all horizontals are parallel and all verticals are parallel with such absolute certainty. Yet it's demonstrated so many hundred other 1,000 million ways.
Yep.
But he's absolutely positive. He's so confident. Like when he was given lip back to the Ordnance Survey UK, they engaged him on Twitter, and they said, and Bev had to say, oh, whatever imaginary coordinate system you're trying to project or something.
Hey, Rumpus.
Hey, Blue. Hey. Thanks for letting me on. I promise to behave. Yes, I think what amazes me, I don't know if you heard Bev I only seen a couple of his things recently, but he was saying that anybody who isn't a professional surveyor shouldn't be commentating on surveying issues. He's not a professional surveyor. So why is he commenting on surveying issues? Why is he not leaving this solely to Larry here or something, or Jesse, or the chap from Maine? The double standards that guy operates is just ludicrous. And he's never read a surveying book. He hasn't got a surveying book, yet he claims that spherical geometry doesn't exist. I mean, the guy is so unbelievably conceited and ignorant. I mean, it's Dunning-Kruger squared, really, isn't it? He doesn't understand something, or he doesn't want to understand something, therefore it doesn't exist. And what's more, he feels entitled to lecture to others like Larry, who's a professional surveyor.
But the thing is, when it comes to elevations, you're not dealing with spherical trig.
Yeah.
You're dealing with a vertical plane. And then it's all right out of Euclid. And every time, as I said earlier, every time Euclid, in the book of Euclid, anytime the page has a circle on it, Bev turns the page and makes no reference to it.
One thing, is differential leveling and direct leveling the difference whether or not you use backsights and foresights? Is that what differential leveling? If you're doing differential leveling, you have to include backsights and foresights. Is that correct, Larry?
Well, yeah, differential leveling and direct leveling, that's kind of the same thing. That's like the difference between a radius and a diameter. I mean, come on.
Right, so differential leveling doesn't necessarily require backsight. I mean, presumably, I've got a surveying book.
Differential level, yeah, you're always involving a way to determine the instrument elevation. So you're having a point that you're holding as your known elevation, and the fact that when you read that, it goes in the left column, and anything else of unknown you put in the right column. That's a backsight and foresight. That is direct leveling. That is differential leveling. It's the same thing. If you said direct leveling, that means you had up an instrument and you read the instrument's elevation, you read a known point and then read unknown points.
Right.
Differential leveling may imply you're making a bench run to where you're starting, off site and have to carry your elevation onto site. That may imply that, but that doesn't mean it. They're indistinguishable.
I mean, because I've got an engineering surveying book, and I've read others, and they don't talk about this backsite and foresight lark. And I'm presuming it's because they're presuming they're just doing planar surveying. It's not. It doesn't claim to be a geodetic surveying book, and so I presume that all the surveyors that wandering around on construction sites and things, they don't have to worry about backsites and foresights because, of course, the errors, unless you want to worry about refraction, I suppose.
No, well, they do have a backsite.
But why would you bother? If the effects of refraction, I mean, okay, perhaps the refraction is bigger. Well, actually, no, it isn't, is it? It's slightly, no.
Okay. It's a small area. But when you set up
so I'm saying, why would you bother with backsites and foresights and go through all that eliminate this eliminating of using that procedure when you can just use your one site? Because the refraction and the curvature are so small over a few 100 meters or so rectangle, why would you bother?
Okay, we're talking about two slightly different tasks. Okay. One is carrying an elevation some significant distance. So yes, you're going to start off site, say a mile or two, and then you're going to have to carry that elevation, backsite, foresight, differential leveling to come onto site. Then you set your instrument on site. Now you're dealing with a small area. You're dealing with, setting of concrete forms, grading a parking lot. You put the instrument up once and you read a backsite. And then you have 20 foresights or 100 foresights. Now, the thing is, they're all short distance and you don't give a rat's ass about a 16th of an inch.
Yes. So are you saying then that, I mean, obviously I'm not professional surveyor, not, but so when you build something, is it always going to? Do you always have to have a benchmark to say what the elevation is? Because you've got some drawing, presumably, of a car park or a building. Do you always have to go and get the right elevation for this point, or can you just say, right, I'm going to say here is my starting point, and everything I do from here is going to be relevant to this height? I don't really care that this is 1 foot, 2 foot, or 3 foot elevation from, or is that specified in the drawings what the elevation must be exactly?
It's absolutely specified in any reasonable construction plan where they call out the project benchmark or an elevation of a specific point. And when you're the one responsible for laying out the forms, you have to put all your elevations relative to that point. Now, they may have an elevation of, say, 1350.295, and on the drawing, they may have just like truncated the 1,300, and everything is like 51, 53, 55. Yeah, but you're still, if you have to come off a reference mark, you have to key to the plan.
Is that the reduced level, isn't it? There's a term I saw about reduced level, which is the local elevation relative to some benchmark you've decided as your sort of origin, and everything could be referenced to that. It's just but you're saying that always has to be.
Yeah, if you're for instance, if you're building a construction and you have development to the left of you and to the right of you, and for drainage purposes, you have to be, commensurate. You could base it on somebody else's parking lot, so that, and they just call that 100, and they'll call that on the plan. Yeah. See this little corner of this concrete? That's 100, and from there they have all the grading. So, but you get to the next property, you're continuing the proper, inch and 2.25% slope or whatever is required to make the.
So in that case,
it's called out on the drawing. Now, sometimes with a major complex like a half mile long, warehouse factory complex, they're going to have 2 or 3 or 4 of those points called out, and you are absolutely obligated mandatorily to use that as your backsite for everything else you do, which are foresights.
Right. Okay, that's interesting. So that's where the overlap I didn't fully understand. So, but you were saying there that you didn't therefore need to have your drawings with a particular elevation. You just said relative to some, as you say, a corner of the next building. You've got your drawings relative to that. You've got them all relative to one another, and you're saying, well, okay, even
if somebody's building a $20,000 garage and some builder plan has come out and said, okay, here's the pad elevation and here's the slope. that elevation is relative to what? Even if it's just the center line of the pavement of the road to which your, the driveway has to mesh with, but it's going to be called out, and you can't, you couldn't reasonably just go out and just set up your level and start going around. It goes, wow, how did that pad end up like a half a foot too high? Well, because he made no reference to what was on the plan. So yes, every good construction plan in the notes, it'll have a call out of the project benchmark or a specific, identifiable point, and the elevation that the engineer used, independent of it, whether or not sea level or just assumed.
Right. So if that benchmark or that reference point is quite close to where you want to do the work, then you don't need to worry about backlights and voice. You just, as you said, they're all foresights. And you just simply
Absolutely, and that's why on the project benchmark or the project elevation benchmark of reference will be on site for that reason. You're not gonna, you can't, lay out, say it's a nice, 4-acre estate, and it's going to take a lot of grading and stuff. They're not going to call out an architectural project benchmark that's 3 miles away.
Yeah.
Really, very much depends on what you're doing.
Right.
If you have project plans for like 8 miles of sanitary drain line, those benchmarks could be, significantly, separated, and you're going to, as the laying out the construction, you're going to have to carry bench, and you're going to have to do a lot of setup and do a lot of check-in, right? But if you're just building, like I said, a house, a half-acre, grading plan.
Of all the houses I built, I only know the elevation of one of them, just one.
In true elevation, but relative elevation.
The only reason I knew the true elevation of that one was it was built in a floodplain, and I and I had to get the floor elevation above the 500-year floodplain.
Lou, I don't understand how you can be building houses, flying aeroplanes, doing a lot of electronics and other stuff. I don't know how you've managed to fit this in. It just stuns me. Amazing. Anyway, just, yes.
Yeah, that was the one and only time I had to prove the elevation.
And did you determine that on your own, or did you have to refer to a licensed guy?
I hired a surveyor.
A licensed guy?
Yeah, very much licensed guy. And he came out and set the elevations for me.
Yeah, the company I worked for, we used to do that all quite routinely. It was called a flood cert. And when someone is buying a house and there's a mortgage and there's a question, is it in or out of the floodplain, we would have to do a flood certification. And you don't want to be wrong on that, because you could either impose like another $1,000 a year premium, or get the property, the building permit, rejected. As opposed to, if you were a little more careful, you would have found the whole, that pissy little 3/4 of a foot made all the difference.
Jesus Christ.
But the rest of the time, they've got a house seat cut in the subdivision you're building in. You don't worry about it. You set the elevation where anywhere you like, really.
Yeah, surveyor, you can understand why they're certified surveyors, can't you? Because if they just make one little error, then someone else goes and builds on that, then there's quite a big bill to be sorted afterwards.
Well, the company,
doesn't work.
One of my first major construction projects was like a $3 to $5 million railroad bridge and grade separation, and it involved all kinds of things. It was in the elevation of the lowest point was like 5 feet below sea level, and the highest point was a bridge overpass, which was like 70 feet above sea level. It had railroad grades, railroad curves, bridges, bents, abutments. Right? We got paid, over $100,000 to lay that out, and I'm working pretty much, as a project surveyor. I can make a $500,000 mistake. Mm-hmm. The guy building it, he can never get more than $5,000 or $10,000 out of kilter before he gets fired.
Yes, I can see why you needed some pass some decent exams to be a professional surveyor. Whereas, of course, Bev has got a GCSE certificate, which is something that a 16-year-old gets. It's a very low. At 16 we had O levels and GCSEs, and the O levels were above that, and he got a GCSE for his surveying thing. So
And then his surveying thing was like a trade school to lay out concrete forms.
Yeah, I think he probably only ever held a bloody stick. That was probably all he ever did in the rain. That was probably as much as this is. And he still doesn't understand that a theodolite has got a bloody a compensator in it, effectively a little pendulum.
Yeah, his stupidity, the surveying methodology, its tools, its maps, everything about it is he's void of all that information, and then he'll speak with certainty how all surveyors are wrong.
Yeah, it's amazing, isn't it? I mean, this is Dunning-Kruger squared. I mean, it's just you could not be more ignorant. He's contradicted by all of the literature he could possibly ever have, and presumably that's why he doesn't have any of the literature or read any of it, because it contradicts what he says. So,
his stupidity factor is idiocracy times the square of the minutes of the video.
And as someone commented, he spends more time psychoanalyzing people. I mean, he'll say that Blue's got some scheme to do this, or you've got some scheme to do this, or Jesse's got some scheme to do this or the other. Everything is being psychoanalyzed because I think he doesn't actually want to talk about the geometry very much. I mean, this is a guy who doesn't understand that a point on a curve has a slope. Something that, a 15 or 16-year-old discovers when they do a bit of calculus. He does not understand this fundamental fact. And if you don't understand that fundamental fact, then you don't realise that you can have angles to this slope.
One of the greatest accomplishments of the UK is their geodesy. That's why the zero meridian is in Greenwich. And their mapping of all sorts of their colonies, the Department of Colonial Surveys, was one of the greatest, accomplishments going, and he just completely pisses all over the UK's greatest, contribution to sciences.
Yeah, I mean, he doesn't have any respect for science, does he, or reality, or people? I mean, he has no respect for anything except.
Yeah, he's surrounded by technology, and he hates the academics that insist on how it's put together, how it works, how it's designed, and he goes, "Oh, they're all wrong."
And he hates maths. I mean, when I asked him, whatever it was 6 months ago, if he could tell me what the gradient of the curve was, x squared was at x is equal to 3, he couldn't do it. He came up with some sort of procedure, some sort of graphical procedure, because he had no idea that we had a mathematical procedure for doing this. So, I mean, when you're that ignorant, and he talks about curves and angles to curves, and yet he doesn't understand that simple point, that simple piece of knowledge that Newton and Leibniz discovered. 300 or 400 years ago.
He was cracking me up really hard a while back when he said, someone was talking about, the 8 inches mile squared, or the spherical excess as being, 1 second for 72 square miles. Oh, all your miles are square. You're talking, you got 90 degrees in all those corners. That's a square mile. No, miles squared. Okay. Yeah. In differential leveling, or the surface area of an irregular shape is still in square units. He goes, but it's not square, is it?
I wonder if he understands the idea of squaring something and having units, and because whenever you square something with units, you end up with a unit squared, which is indeed square, but it's not. The units are not squared in that.
Like a circle. An area of a circle is going to be in square units, but circles aren't square, are they? Yeah.
Yeah, you're probably right. He probably doesn't understand that, does he? Yeah. I mean, he's obsessed with the grid. Whenever you see pictures that Blue was showing of that I do wish people, when they're doing GeoGebra demonstrations, they wouldn't put things at the top of the bloody circle, because these always gets it's a special case where the line follows the grid. I mean, whenever I do a diagram, I always put whatever it is, the tangent point I'm dealing with, at sort of about 2 o'clock, to make sure that people like Bev and others don't start lining it with the grid on the paper, or trying to use special cases, or thinking, that drives the page and others absolutely nuts when you say that this is a horizontal, and of course it's not horizontal on the page, and of course Bev has been known to say, well, it's not up the screen, therefore it's not vertical. But if you start drawing things at 45 degrees or 2 o'clock on a circle, then that avoids us. And I know that Flat Earth Math always draws everything horizontal and vertical, and it just means that you're dealing with a special case that they can latch onto, and people really should draw diagrams with not the special cases, as an aside anyway. It just drives me nuts.
Just anyway. Like in the video that Blue was shown, where Petey, sorry about that, where Petey had drawn a quadrant, and he put the origin on the circumference, not at the center. He goes, well, you can't draw an arc with without the 0,0 at the middle, can you?
Yeah, I mean, they don't understand coordinates. He doesn't understand maths. Yes, that's incredible, wasn't it? That was absolutely amazing. They don't understand. For instance, I mean, I don't know if I'm not sure if Bev thinks a line is 1D or 3D. And I think I was having a chat with someone in the chat there, and whether Balanced Truths think, he wouldn't answer me whether or not a line is 1D or 3D, because I think Papers previously said to me in one of Bev's debates when I was prepared to go on his Discord. I think he said that depending on the orientation of the line, it's 1D or 2D or 3D. What? There's so he thinks the property of the line, its dimensionality, varies with its orientation. When not realizing, of course, you can just simply change your grid or your grid system to do that. Yeah. So you're saying your line is changing its property simply because you've rotated or manipulated your coordinate system. Oh. Don't think that changes the fundamental properties of a line. Thank you very much. Yeah, so they're obsessed with grids.
Well, we've all gone through all that crap with those guys over and over and over again. They don't get it. They refuse to understand it.
They don't want to, yeah.
A point is no D. It doesn't have any D's. It's a point. But it can exist in 3D space.
And the key thing is a point on a curve, because it's on a curve, can have the property of a slope. Whereas they sometimes might make the argument, well, how can a point have a slope? Well, by itself, indeed, it doesn't have a slope. It's just a point. But when it's part of a curve or a line, it has the property of a slope. And that's the bit they do not get.
It's not the point that has the curve. The curve has the curve.
Yes, that's but when you pick on the point on the curve, that point on the curve has a slope.
It's the curve that has the slope.
Yeah, but you can pick on a point on it, though, can't you?
Yeah, but
you can say this point on.
And when you say the slope, you're not describing the point. You're describing the curve that passes through it.
Yes, but that is at a point. It is only it's infinitesimally small. It is a point. That's what calculus says. It's infinitesimally small, and that infinitesimally small point, because it's part of a curve, has the property of a slope. Because it's part of a curve, I completely agree with you. But it is a point. You're saying this particular point, this infinitesimally small point, and it has a slope there.
But the slope is describing the curve, and the point is just an address on the curve. So when you talk about the slope, it's the slope of the curve. Now, let's get back to it's at the point. Does not mean it's the curve or the slope of the point. It's the slope of the curve at the point.
Yeah, true. Yeah, okay. You could. Okay, but it's at that point. The point is that point on the curve has the property of a slope. Then, okay, that point on a curve.
It's the curve that has the property.
Okay, I'll give you that.
Thank you.
But it's at that point. The point is that point by itself, and being part of the curve, has the property of a slope. An infinitesimally small point.
Okay. Just to take it one last notch, and then we got to move on. What if you had two curves intersecting at the point? Yeah, each curve has its own description. The point is just an address.
Yes, I'd agree with that. But the point is, at that point, there is a slope. even though it's infinitely that it has no length. That point on the curve does indeed give it that point, or that you say it's an address. That point has that property thanks to the curve of that slope. And until Bev understands that basic point, because the trouble is, if you start explaining in terms of making it smaller and smaller, and it confuses the issue somewhat. I mean, you have to start to explain to him those approximations and things, and he's never going to understand that, is he? Whereas if you can say we have a formula for, say, an x squared or a circle, we have a mathematical formula for telling you what the slope is at this very infinitesimal point. This exact infinitesimally small thing has this property of a slope, and we've got a mathematical way of describing it. Anyway, but he's not going to. Yes, but that's the problem. He does not understand that this point can have the property of a slope, and that's so. All the description that that video, unfortunately, I don't think you're going to get anywhere. And also that woman who described that formula for the angles between two curves in that video, of course, it doesn't cope with the infinite case of when the gradients for vertical lines, of course, because you can't have gradients.
That's
they
right.
don't cover all the lines, so it does have some problems.
Yeah, you got two possibilities there. One, you can have you can end up with 0 in the denominator.
Yeah.
And if that happens, then the function is undefined.
Yeah.
And that's where it's perpendicular.
Yeah.
Or you can have a 0 in the numerator.
That's fine. That gives you a valid.
Yeah.
That gives you the correct result. But if you have the
right.
You can't hold infinities or whatever it is. If you can't have a gradient of a line. If you try and describe a gradient of a line, you can't move along it and things. If it's vertical, if your formula is y is equal to mx, you have there's no mapping between the x and the y, and so you have to use different sorts of ways of doing it. You have to use vectors and things, and so there are better ways than the formula that she used was not universal.
Well, she was doing a 5-minute video too.
Yeah, indeed. Yeah, yes. I mean, it's probably even hers was too complicated for Bev, I suspect. I mean, if he doesn't. I don't think he understands that y is equal to mx plus c is the formula for a straight line. I suspect he doesn't know that.
Yeah, I thought.
If you asked him,
I thought it would be interesting though, just to show.
It was. No, I agree with you. Totally agree with you. I think it was a very valuable. But if, for instance, I don't think he could work out.
All we need to know is what the derivative of the function is, and if we know that, then we know what the slope of the function is at any point.
But he doesn't know what the derivative means, of course. He doesn't know what derivative means.
And with that, we can find the angle, and you can go back and prove it to yourself by doing what I did: construct the damn tangent and measure it.
Sorry, how did you measure the tangent?
She calculated the angles.
Oh, right, yeah.
From the line to the curve. I went in and threw tangents in there, and then measured, the angle between the tangent and the line to see that it is in fact the same thing that she gets. Of course it is. Right.
I mean, he couldn't work out the intersection between two lines. I don't think he could do that. I don't think he's got the mathematical skills to do that.
Oh, I'm sure that went way over their heads.
Yeah, I mean, this is a guy talking about geometry, and he would not be able to work out the intersection between two straight lines. I think Clive, of course, has always got the mathematical answers to everything.
Oh yeah, you bet he does.
Yeah, indeed. I mean, he was describing earlier about how you can prove that the tangent to on a circle is perpendicular to the diameter, and I must admit, he gave me a formula. I didn't fully understand. It involved the differential of the ds of the length, and I was just thinking how I'd prove that, and he did give a very quick proof, which I didn't haven't yet had a chance to involve, and he's just given another proof here of the arc length. Yes, he was using dot products. Okay, I thought that's what he was doing. Yeah, right. Yeah. Anyway, so I don't suppose Bev even knows what a dot product is, for Christ's sake. Oh, here we go. Balance truths. A point has no parts. Yes, balance truths, but it can be a point on a curve, and a curve has a slope, and the point at that point on the slope has a slope. Point on a curve has a slope, and if you've got a slope, therefore you can determine what the angle of that slope is to some other line or curve as well, because you can get the slope of the point on the other curve if you've got two intersecting curves. You really ought to try listening balanced to, well, anybody, really.
Not that hard to do, guys. It's high school mathematics.
Yeah, Blue, what age were you when you understood how to get the slope of a curve? How old were you when you...
Oh, I don't know, probably 15 or 16, something like that.
Exactly. So, and this is the thing. Bev is below the level you were when you were 15, and Alan's also competent. I mean, everybody in here, and obviously Larry. So yeah, he's at the level of less than a 15-year-old. That's the sort of person you're dealing with here, who believes, for some unknown reason, thanks to Dunning-Kruger, that he's because he's got a GSc in surveying, he thinks he can talk about surveying. It's quite extraordinary.
Rumpus, I will have to admit that thanks to my health conditions, these days I would have to go and look a lot of this stuff back up to use it again.
Yeah, but Alan, you know, but you know it.
I used to be able to do dot products, but I couldn't even tell you what one is anymore.
Alan, it would take you 5 seconds to refamiliarize yourself with it and be able, and perhaps a minute before you could get back into the groove, or well, perhaps 5 if you haven't thought about it for 20 years or something. So don't. Yes, I mean, you can get out of faith, but your speed with which you can reacquire those skills when you've learnt them once is really rapid, and he's never made that journey to even ever understanding it. So I wouldn't worry yourself.
I don't.
Well, okay, great. Okay.
As a certain Mr. Eastwoods would say, a man must know his limitations.
Yeah, but yours is not limited. I have confidence in your ability to work out cross products and dot products and things, whereas Bev doesn't even understand what a dot product is. He doesn't even. I suspect he doesn't even know what a vector is. And the cheek of the guy. I mean, to abuse Blue and you and me and I mean, one thing that annoys me is where he abuses Charles, Flat Earth Math, and then Flat Earth Math, how much he's enjoying it. I can't believe he's sincere in that, I'm afraid. It's one of the things that I find slightly annoying. But he specialises in abuse. That's what he does. And then based on nothing but malice, really. He doesn't want to learn, does he? That's the key thing. He doesn't want to learn.
But then we all know that Bev and most of the rest of his cronies are all Delta Lima Charlies.
Remind me what that means.
Disingenuous, lying.
Right. Right. Well, no, I think they're more stupid than that, actually. I think it's that they've got this confidence born of stupidity and not understanding. And I've noticed this, that the people, these guys don't want to learn something because that they suspect that by learning a bit more about a subject, that they'll start to erode their confidence in their beliefs that they hold. Because if they don't understand a subject, you can just believe what you want about it. So that's Bev's situation. He knows that he's done a bit of Euclid, the sort of childish stuff, and from there he doesn't want to learn anymore because he knows that might conflict with his. For some reason, he believes the horizontal is level, even though if he were to pick up a surveying textbook, it would tell him that completely otherwise. It specifically says, if you go to any surveying textbook on chapter 2 and mine, it shows you a diagram of the difference between horizontal and level. And anybody who's got any surveying textbook will see that. But, he doesn't want to look in a surveying textbook when he's challenged on this because he knows that will challenge him. And that will challenge his beliefs. So I think it's a weapon of what I call about the shield of stupidity and ignorance. If you keep yourself stupid and ignorant, then you can fend off arguments of logic because you don't understand them. And he doesn't understand what calculus is or points on a curve. And so by doing that, he can then be confident in hanging on to his beliefs. Whereas if Clive said something to me, for instance, Clive Wells, and I didn't understand it, I'll be terrified, thinking, "Oh God, I don't understand this. I'll just shut up about that subject and until I've tried to understand it." Whereas their opinion is, "Oh, I don't understand it, therefore I can pronounce on it." Oh, nice. I presume, Alan, did you have to do any sort of maths and stuff in your flying and your electronics and things? Did you have to do any complicated integrals and differential stuff?
Well, I did it when I did my RAF training. I did BTEC level 3 maths, and then of course I did a degree in electronic engineering. So
Quite, yes.
yeah, I did the usual electronics maths for engineers stuff.
Yeah, indeed, which is what I did effectively, because I did physics and I did some electronics courses as well. And actually, the electronic stuff was actually some of the more difficult stuff that I did. All those flipping. Did you anything? Things like Chebyshev filters. Does that mean anything to you?
Yes, yeah.
Oh my God, Alan. Okay, well, right, you're right. You're pretty hot then. Oh, okay.
Oh, for God's sake! Shit. Yeah, the word you just said. I'm not now
Right.
going to try and say because it's not going to come out right.
Right.
Chebyshev.
Yeah. Well, yes, Chebyshev. I mean, George, for instance, he actually used quite complicated maths in what he had to do. He had to understand this, the maths, and actually employ. Whereas I didn't have to do that because I mean, my physics when software, I didn't really have to get involved deeply in maths. So you've done Chebyshev, you've done more maths than I have there, in effect.
Yeah.
And George actually did that in the real world.
That's when you realise that digital signal processing makes life so much bloody easier.
Right.
Because you know you can build a digital filter that will cut off at pretty much the exact frequency you want.
Yep. Digital stuff is always easy. The digital courses are always easier than the analog stuff. Bode plots and goodness knows what, and transfer functions and poles and zeros and things. Oh. And of course, George lived with those things. I mean, he was using real quite tricky maths throughout his life.
Yeah, if you're regularly designing analog electronics, you're going to be using quite a lot of fairly complicated maths all of the time.
Yep. So George had to do it in the real world, and I think Blue I think did some quite tricky.
Blue would have done as well. Yeah. I mean, I was unfortunate in that my health issues, my serious health issues, started it pretty much 3 weeks before I started my degree course.
Oh dear, I'd like Alan.
So I have never worked as a professional electronics engineer.
Right.
I got my degree, but I didn't. I was never well enough to work full time.
Yeah, and there's a big difference, of course, of doing it at degree level and then actually doing it in the real world. So I'm sure Blue, who's done to do this.
Indeed, there is a huge difference between what you learn at university and doing the job in real life.
Yeah, but things like things like bits of software and things. God, yes, there's no comparison. I mean, Blue knows what a bloody what an alpha function is. What is it? It's an alpha function I'm thinking of. Damn it, I've forgotten the bloody name of the thing I tested you on before you knew, which I always regard as a test of someone's mathematical knowledge. Yeah, I think it's alpha function. Yes. Or alpha series. Anyway. Yes. Anyway, so all this is completely, if we start talking about in these terms, I mean, you see, Bear, for instance, I think he was looking at something that Larry had done and Jesse, and he said, look at all these numbers that no one understands. I mean, just a simple sort of Larry's I think was showing the height to the I can't remember what it was now. His profile, some profile or something. Or was it one of his? Well, I can't remember now. It was a really relatively simple thing. And but Bev's answer to this is, oh look, it's massive that no one understands. Therefore, because I don't understand it, I can therefore dismiss it. And that's how stupid these people are. Gamma, thank you, 2 left thumbs. Thank you very much. It's gamma function as I was thinking of. Thank you. Yeah, I'm a bit sleepy today. Yes, so the trouble is they've got this shield of stupidity and ignorance, and then we've got to fight it through. And the only way I find that you can actually fight the way through to it is with diagrams, very simple diagrams that they can't argue with. And things like zooming in on a curvy thing, say, look, there you are. This is what the slope is of this curve at this point, and we can show you that by zooming into it.
Yeah. I think I must have been a very odd young person as well, because I used to really enjoy if I got the chance, watching Open University programs.
Me too.
In the 70s, like wouldn't have a clue what they're on about, but you just watch it anyway and like follow along with
Have you
whatever
seen
they're
this?
saying.
Have you seen the scary Open University program about non-Euclidean geometry?
I can't remember now.
Dev has actually got clips of it. He occasionally puts into his videos, and it's got the bearded guy showing you this, and trying to understand that Open University program. I've seen it about 3 times, and it's still I can't quite get it right. I still can't fully understand what they're saying.
Is this something from the 70s by any chance?
Yes, it is.
Oh,
yes,
good. As long as it's from the 70s, like you say, with the bearded bloke, with the cardigan, with the leather patches on the elbow.
Absolutely. Yeah, so I completely agree with you. I think they were great programs. They really were. Yeah. So in case people don't know, in American, that we had this sort of Open University is a thing as after you're working you can do. In fact, my father did an Open University degree, and he became a doctor, and he it's something you can do in your spare time if you want to do it. But you can do it full time as well, and they're sort of done by you get these books and you just have to answer lots of questions. And they're very well written books on the subject. And then you every 6 months or so you go off for a 3-week on-site lectures as well. And they were very well regarded. And the programs they had on the BBC late at night or early in the morning were exceptional.
My ex was doing an Open University degree, history and archaeology.
Right.
In fact, she had to do a weekend dig on Salisbury Plain.
Wow.
And she was able to take my then 11-year-old daughter with her. And the dig was being overseen by the guy off Time Team with the hair and beard.
Oh, the field archaeologist guy.
Yes.
Right.
Phil.
Phil, yes, it's Phil. Yes, Phil somebody.
And yeah, she said he was absolutely brilliant, and they let her dig, and she recovered a Roman coin and a Neolithic arrowhead.
A friend of mine who's on this,
which of course are now in Wessex Archeology's main collection.
Right, so she got into a museum then. I see. Right.
Well, it's in there with all the other stuff that they recover. But yeah, it's you could literally go and look at it, and it says on the thing, that it was her that got it from the dig site.
My friend Nigel, who will be featuring in my Rect test, who's been there, one of my mainstays, he did an archaeology thing for a week or a few days or something about 3 or 4 years ago. He said it nearly killed him. It's absolutely physically deadly. So that's, so Open University is good, definitely.
Yeah, I mean they're proper real degrees, and they are recognised.
Absolutely.
In fact, they're recognised worldwide, and of course, OU has a lot of international students as well.
Yes, and they make programs. You quite often see some of the Brian Cox videos, for instance, that we'll say in association with Open University or something. It's quite a lot of the BBC programs and science programs, or what are called Horizon programs. I don't know whether that's what they're called in the USA or elsewhere. They're quite often associated with the Open University, because it's a prestigious, a prestigious thing. And Clive Wells said he saw an Open University program as well that had something about residuals in calculus or something. And Two Left Thumbs is saying he saw lots of OU on BBC Two after the main channel shut down. Sounds like. And Two Left Thumbs also said he was interested in participating in Rect, and apparently I think he lives quite close to that site as well. So quite close to you, I presume.
Well, yeah. I mean, I'm about an hour's drive.
Yeah. And of course, Two Left Thumbs is the thing that he's the guy, isn't he, who did all that stuff for Blue on the Cavendish project, isn't it?
Yeah.
Isn't he the engine?
Oh, yeah.
Brilliant guy, yeah. Wow, brilliant. God.
Yeah, that's a lefty. He did the adjustment thing.
Which was your key thing, wasn't it?
Yeah, that's one of the most important parts of it.
How's that going, Blue? Is it still doing its thing in the university?
Oh, yeah. Yeah.
Brilliant. Have you been to see it again?
Not lately. No, not since I went down there for the whatever that was back in the spring.
Who was the flat earther who was threatening to go there and complain about it or something? Rakia Life.
Yeah.
Right.
Want to turn up and make a party of it.
Right. Yeah. What a git. I noticed he's fallen out. Now, by the way, talking about how obnoxious Bev is, he's fallen out with that monkey guy. Oh bloody hell! And Rakia Life doesn't go on there anymore, does he either? So Bev is gradually going through a team of people annoying them. And
Rocky has been banned from just about everywhere.
It was really odd, actually, because when he started off, he was quite a pleasant guy, but he gradually got more and more obnoxious with time.
When was he pleasant?
Well, he wasn't obnoxious, okay. Yeah, sorry, Farmers. Yeah, he wasn't obnoxious. When he was quite diffident when he first turned up on, was it Jose's?
Yes, yes.
So there you go. So he was all right then, but gradually, as time went on, he got more and more obnoxious.
Yeah, it didn't last very long. He quickly turned into just a vile piece of shit, like most of them have.
Right. There are the odd flat earther that's not objectionable. I mean, SC Montreal it seems to me one of the better ones, and still stupid, of course, but he's not maliciously obnoxious like Bev or Rakia.
Oh, I don't know.
Oh, okay. I'll defer to your expertise in this, Farmers.
I mean.
Montreal. No, he's got maybe a bit more passive aggressive, but he's still stupid and passive aggressive.
Yeah.
We've still got Balanced Truths in the chat who doesn't understand why a surface is 2D and the surface of a sphere is 2D. Oh.
Well, none of them do.
No, they don't. No, it is. You're right. I think, Farmers. I don't think there's any flat earther that understands that a 2D surface is 2D, because that's why I keep on asking how many dimensions he thinks a pencil is, and because once you ask them that question, they think, oh, hold on, has that got to be 3? Then there's the question of someone answers it depends on the orientation. Some of them say. But once you start questioning about what they think a pencil is 3D or not, or it's 1D, but then why then, because it can move around in 3D space, but yet we still call it 1D, then why can't you understand that a surface, which is 2D, but lives in a 3D space, well, of course, we don't know it's not living in a 7D space. That's the key thing. We could be living in an 11-dimensional world, but we refer to the properties of the thing that it's got, whether that's 1-dimensional, 2-dimensional, 3-dimensional. That means basically, can you describe it with a certain number of coordinates? Can you visit every bit of the space you're describing with a certain set of numbers, and with a line you can visit every point on it with one number. On a surface you can do it with 2, and in 3D1 you can do it with 3, and if you didn't 4, you can do 4. But just because a 3D space or 3D object lives in a 4D space doesn't make it 3D. Its inherent properties are still 3D, just like a line, its inherent properties 1D, even if you've got a line in 3D space. And they don't understand that. Here we go. Got him saying in reality everything's 3D. So he doesn't believe lines are 1D. And if Blanche's truth was to be told, I'm afraid it's 11 dimensional space, then presumably he thinks everything is 11 dimensional. Silly person.
Very silly.
Okay, so if a surface is just 2D, then why is it that if I have to paint 5 square meters, I'm going to need a volume of paint?
Because paint it's got thickness. Paint has got thickness. It's not geometrically like all things.
I know.
I know you know. I knew.
It was one of the arguments I heard, I think it was Mabbott. He would come up with the fact that it's like there's no such thing, all surfaces have thickness. He said, got to be, because I need a gallon of paint to paint my car. Yeah, why do I need a volume if it's only 2-dimensional? Of course it's 3-dimensional. The surface is 3-dimensional. Like, oh, get out.
Yeah, I mean, this is also the problem that Flat Earth Maths has got. He doesn't understand that geometry is deductive and abstract, and that when you apply it to the real world, you say, "I'm going to," and you got it exactly right, Larry, when we were discussing it in the last hangout, that you change your geometry. Your geometry can never be wrong because that's been proved deductively. But you've got to pick the right geometry for you've got to pick the relevant geometry to your situation. So if we live in an 11-dimensional space, you've got to pick an 11-dimensional geometry, and if you find there's a problem between your reality and geometry, you've picked the wrong geometry because the geometry has been proved to be correct. And this is something that Flat Earth Math doesn't understand, even though he's a bloody geometry teacher. This was driving me mad. And he dismissed that argument I was making. It's just, I know I'm a geometry teacher, therefore you don't know anything. And that's what got me so annoyed with him. But yes, so you've got to pick the right geometry for reality. But geometry is provable because it's deductive. You start off with some axioms like Euclid does, and from there you can prove deductively everything's in there. But as Larry said last time, you've got to pick the right geometry for your reality to see that if it's useful in that reality. And if we're in an 11-dimensional reality, you've got to pick a geometry that's 11-dimensional. And you might, and this is, of course, Bev's problem when he's doing this realizing Euclid thing. He's doing something in the real world, and he's then going to say, what happens if he were to find there was a problem between what he does in the real world and his Euclidean model? You can't invalidate the Euclidean stuff that you've done by something you've done in the real world. It means you've made a mistake in the real world, or the real world is not using the geometry that you've chosen, because the geometry cannot be wrong. It's been deductively proved. So if you have a problem with reality and the geometry, you've got the wrong geometry. And obviously you can make mathematical errors or human errors in the way you do things, but the geometry is proved, and you've just got to pick the right one for your reality situation. And there are people, physicists, who believe in picking 11-dimensional geometry for our reality. They might be wrong. We don't know. But the idea is you pick your geometry to match reality, and if there's a problem, you you pick a different geometry. And I think was it Left Thumbs was making an interesting point about he was making a point about sphere surface being 2D, like a point having the property of a slope. Yes, indeed, sphere surface being, yeah. Do you mean to say something, Larry?
I was just thinking about when someone was talking about the difference between the different methods of calculating, coming down to a precise diagram and then scale the diagram, which means if you have a high resolution CAD program, you can do more accurate work than with a lower resolution CAD program. And I said, what bollocks is that? The math is absolutely, there's no loss in precision if you're using chalk on a chalkboard.
Yeah, I mean, maths is...
Yeah, they didn't understand. Chalk on a chalkboard is just as good as your $50,000 CAD program.
If you've got
Just
the
one
maths, if you've got the underlying maths, because the maths is provable, and that's going. If you're just using a representation, it's just a chalkboard.
It's the same thing. It's the same thing. It's just a CAD program is just improved chalk.
It's just that the CAD program will let you do the calculations somewhat faster.
No, it does it for you. You don't do any calculations.
True. Yeah.
The CAD program is an abstraction from the maths.
Yeah. The CAD program saves you having to do the calculations, and it does them at a much faster rate than a human ever could.
I haven't used AutoCAD. Can you generate little mathematical procedures inside to do things for you, so you can actually do mathematical stuff, right?
There's an underlying scripting language that goes with whether you're using AutoCAD or whether you're using Bentley or, and you can even go back to things like Quark Express, which was a desktop publishing program.
Indeed, that was a program that I used to compete against that program, and my program beat it in a international competition. So
I used to write all kinds of AutoCAD 12 scripts. Yeah, it was just amazing. But there again, a polished CAD program, and you get some student that can wield a CAD program, didn't learn a frickin' thing.
I just used to fix it when you guys used to break it.
And of course, one thing I've been playing around with is Jesus Christ, I'm going to bloody blame. Carry on. I've forgotten the name of something I was trying to say.
Harvard Graphics?
Say again?
Harvard?
No, sorry. No, carry on. Yeah. Anyway, so there's lots of scripts in these things. I just didn't, not having used AutoCAD, I didn't know whether that had the scripts. I presumed it did. Yes, balanced truth. Flat Earth Math was trying to teach me, and he got it wrong. Completely wrong. Yes. Anyway. Yeah. So, anyway.
Oh God! One should stop reading the side chat.
Yeah, well, it's quite interesting. There are lots of interesting comments in there.
Sorry, I just had a bit of a laughing fit because of monochromatic light source. I made a dog into a cat, put it in a freezer for 3 days, then passed it through a bandsaw and it went meow.
Oh dear.
That's quite. That's quite right. Okay, that's your sort of humour, is it, Alan?
Well, I couldn't help it. I read it and it was like, well, proper dad joke, isn't it?
Oh God, yeah.
There you go. That's just for Rumpus. So that's kind of what an AutoCAD script looks like. And then there's the representation on screen.
Right. Yeah. Thanks. Interesting. Yes, because I played with a number of 3D things. I assumed it had a script, but I just didn't know for a fact that it did. Yes.
Then you can do things like you can repeat things multiple times, so that's how you can then sort of start to create layers. And anything beyond that, I'm going to throw it at Larry because that's reaching the limit of my AutoCAD knowledge.
Oh man, that is so more slick than what I was using back with AutoCAD 12, and it was just the Lisp routines. And yeah, it was.
Oh yes, Lisp routines. Yeah, I remember that.
Lisp. Oh my God.
Yeah.
Oh dear.
Handy. I never got around to writing any of my own, but you used to pick them up the longer way. You had Lisp routines for drawing flexible ductwork and things like that, or the odd little sort of double curve thing when you're showing a pipe that's been cut, and you sort of do like an S on the end, and then it sort of fills it in, and all sorts of clever little Lisp routines. But I've lost them all over the years. They were bloody brilliant. I'm not entirely sure if they still work with AutoCAD.
I actually had a bit of fun a couple of weeks ago. I had to do. I very rarely have to get out my solder set, but one of the clients I work with has got a VAX 620. And if anybody, that is like, you know, state of the art type technology, because they've got a basic.
Good one. I like that. That's very funny, foolish. Yes.
And the connection to the PS, the power supply in it, have basically fucked up. So I had to take off a couple of resistors and a capacitor off that, and then replace them. And it was weird because one of the problems I had is I had to build out the pins because the capacitors back then were a lot bigger than the ones we have now for the same rating.
Right. Yeah. Quite.
But yeah. But it's working again, so they're happy, and I got paid.
Getting paid is always a bonus.
Oh yeah.
Not bad for a Saturday afternoon work.
Yeah.
Yes, I can imagine they'd be quite pleased to have that working again, whatever it is they had on there.
It was running, basically, it's a company that does aerospace logistics. And this is a program that was written, I think it's like 1986. And they're trying to persuade them to move it to, because it's a single-threaded 32-bit program. And I think it was written in COBOL.
Oh boy.
God.
First, there is one advantage of big electrolytic capacitors.
They go bang a lot better.
No. Well, they if they've got the connectors on the end, it's very easy to take 1,000-volt mega and charge them up, and walk up behind somebody in your in the workshop and stick it on the back of their neck.
Oh, yeah.
Again, going back a few years, one of my friends, he you know, I dabble in a bit of electronics nowadays, but it was his life, and he's like building lasers. That was his hobby, and he had 10 farad capacitors.
Oh, lovely!
Bloody hell.
Yeah, they're the sorts of things that you have to keep the terminals electrically connected at all times when they're not installed, to stop them building up fatal electrical charges across the things just by sucking it out of the air.
Did you know that a 10 farad capacitor will vaporize a spanner?
Yes.
Bloody hell. Hold on. Can you explain to me why it accumulates charge just from sitting there? Why? How? Who?
Ionization in the air.
Ionization, yeah. There's,
but surely that would average out. I mean, yes, but if you have it the same, I mean, we know there's 100-volt every meter you go up. There's a 100-volt change.
That's potential difference, isn't it? Yeah.
Exactly. So if you're assuming your capacitor sitting on the floor and its terminals at the same elevation, where's the how is it getting charged? I don't understand this.
Free electrons.
Yeah, but it's going to be, but it's all going to be symmetrical.
No,
it doesn't. I'm trying to think this through from. I know it does. I'm now trying to think if I know why it does specifically.
Okay.
Beyond what I've said, I don't know anymore.
Okay, so from so even if I think it's theoretically it's impossible, I better be damn sure practically I take some notice of this, right? Okay.
Well, what we can do is we can get something like a 1 farad capacitor, which is still about the size of sort of like a large coffee bean tin. So probably about a 3-liter capacity. That will kill you, but you can certainly, use a meter to detect the charging.
So you're telling me if you're with this, was it 3 farad? You said, sorry, did you whatever it was?
No, 10 farad.
Yeah, 10 farad is the big one. Yeah, I mean, I think the Earth is only 3 farad, isn't it, or something? So you've got. So if I leave it on the floor, if I leave this 10 farad capacitor just sitting there on the floor, after how long will it have a sufficient potential across the energy stored, I suppose, is what we're talking about ultimately, stored in it to kill me?
A week or so.
A week. But
Yeah,
I
I mean, that
this is free energy. This can't be right. What's going on here? This is free energy you're talking about here.
It's not, because whilst you've got to remember the speed that a capacitor will discharge.
Yes, but nonetheless, I don't know how much energy you're saying. Presumably, you're saying the potential will accumulate, and because it's got a certain capacity, you therefore know what the energy that will be. And was it half CV squared?
Rumpus, what you got to remember is it will take maybe 3 or 4 weeks to get the energy into it, and it will take maybe microseconds for the energy to leave it.
Exactly, but it's got to be that amount of energy. So I don't understand where this energy is coming from. I don't understand. It's not possible. I refuse to accept this bit of reality, I'm afraid. I can easily kill myself trying to prove this.
Where does the atmosphere get enough charge from to create lightning?
Well, that's all the rubbing of the clouds, all rubbing one another up and dislodging electrons.
Yeah,
but
well, that happens all the time. That happens all the time everywhere. So if you have a device there that will
but this is at the ground.
Store that charge.
Perhaps is it something to do with this 100 volt potential difference with every meter? Is that where it's getting it from? This is confusing. What? I deny your reality and substitute my own. Sorry, I can't see. This is free energy. I know it's being discharged in a microsecond, but nonetheless, it's still energy. And if you had enough of them, I don't know how much. If it's a watt, for instance, or something, watt hour or something stored in there, then that's energy. As you say, it could be electric. You could think of it like clouds, I suppose, isn't it?
But remember, it's something created those free electrons that the capacitor is then effectively storing.
But why would it gobble up? Why would it gobble up some electrons and not the opposite occur? How can it be? It can't be just an electron sucker.
Well, it's the discrepancy in charge in a capacitor, isn't it?
The what? Sorry, the
density. So it's the imbalance between your positive and negative plate.
Yeah, but where's that coming from? Where's the imbalance coming from? I mean, obviously, if I stick a positive and negative voltage across the capacitor, it will charge up to that voltage. But where's this voltage coming from across the terminals that's charging it? Now that's why I said talk about if it was one of the terminals was at ground level, another one was say another meter high, then you've got this 100 volt potential difference. But even then, that's discharged by the tiniest of currents. So that's why we can't use the 100 volt difference per meter usefully in the real world. But you seem to have struck upon some way of storing this.
It's not actually very useful unless you want
it's still charge. It's still energy, isn't it? I mean, it might not be very much, but it's some. And if you have enough of them, you would have lots. I'm confused.
So it's due to electrostatic charge buildup. So here's an actual statement from.
Two left thumbs is agreeing with me, and he's telling you he's agreeing with me. Thank you. I like two left thumbs. He seems to be a bright lad, actually. I'm looking forward to him helping me with Rect, if I can get him to do that.
But I mean, one of the things I was always taught, regardless of how long, so monitors, microwaves back in the CRT days, regardless of how long they've been unplugged, you always discharge capacitors on the board because the chances are you will get a shock off them. Yeah. And there you're dealing with sort of 30,000 volts at milliamp kind of level. Still enough to make you do a good salmon man if you get it wrong.
A what man?
Salmon man.
What's a salmon man?
it's where you get a really, really good kick off a capacitor. It's high voltage, low ampage.
Yeah, indeed. Why do you call it salmon, man?
Because you lie on the floor and you keep twitching for a while.
Right, I see, salmon impression. Okay.
Yes. It bloody hurts.
Yeah, it's only happened to me once, and that's because I had to use 2 screwdrivers to short out a capacitor on a monitor. I had my screwdriver. In my case, I asked someone to hand me another one, and they handed me a cheap ass fucking screwdriver with a rivet through it.
Yeah, well, you should be using a proper Brinkley stick. You do realise that, don't you?
Yeah, if you had a Brinkley stick, then that would be absolutely fine. I also should have been earthed as well.
It's not like it's difficult to make yourself a Brinkley stick, is it?
No, but you know that most people use 2 screwdrivers and cross them.
Yeah, all right. So, yeah, but
and you do it one-handed because that's how you were taught to do it, so you don't get a discharge across your body.
Alan, we're not all as rigorous and as well trained as you. We're lazy.
No, it's just that actually I was fortunate in the fact that the RAF had numerous Brinkley sticks around the place because of the number of high voltage equipments we were working with.
So here's just something again. Here's a full article backing up what Alan was saying.
Okay. I'll read on that. Presumably, Alan, you and your radars, presumably they had very high voltages, presumably.
Yeah, I mean, I had a colleague who came in and did the shift handover in the NAFI bar one night, which was a bit odd. But when he walked in, one wanted to start laughing because he had the large comedy bandages on his hands. You know, you know when you see the comedy bandages. Well, he had those bandages on his hands
because he'd done something stupid.
Because we had each of the 12 transmitters on the radar had an EHT cabinet, which was fed by a 91 kVA 3-phase motor generator set. Okay, the output of which at full power was 12,000 volts at 6 amps.
Oh dear.
Okay, you went round the front side of it where the big capacitors and everything were, and to open the cabinet you've got 2 handles that you turn and pull down, but there's a big lever that comes through a slot in the door that you have to pull down that grounds everything inside so that you don't get caught by residual capacity in the big capacitors. You go around the other side and you've got the access to the same voltages but just not the big capacitors. So there's a pair of doors and they're held, each door is held shut by 3 screws. So you just undo the 3 screws, swing the door open, because you need access in there with the thing live to do maintenance.
It has to be live for you to do maintenance.
It has to be live for us, yeah, because like when you're setting the thing up, you have to be able to check certain things.
Take measurements and things. Okay, so monitor what's going on. Right.
Exactly.
You're gonna have continuity, man.
Yeah.
So he's opened the cabinet and and the cabinet door's about an inch and a half, 2 inches deep around the edge where the frame is, with a couple of mil, metal sheet over it. And he's grabbed hold of the end of the door. So he's holding it with his thumb pointing downwards, and he's swung the door open. And he's taken his other hand out of his trouser pocket, and he's gone, "Oh, that's the problem," and pointed at it.
Oh, arc spark.
He didn't touch it, but he got close enough.
Bloody hell.
And of course, he's holding on to the rack. The rack is earthed, is ground. So it kind of
so it's a bit like pointing at a high tension line. You get these a pylon or something while holding on to the bit of the pylon and pointing at the high voltage line.
It will jump and get you. It jumped and got him. The first job I had when I got to work, was cleaning the bits of skin that
Oh,
were still
God.
stuck to the door where he was holding the door across the palm of. Basically, I had to scrape the palm of his hand off the door.
I presume he was very lucky that the current didn't go through his heart or something. It somehow short-circuited somehow through his arms.
It went right across him, but fortunately, he was. I don't think he had it. I don't think he had it wound up at full power. When you first turned it on,
Oh, I
it
see.
was only about 2,500 volts.
Oh, okay.
Um,
So it didn't have
and
the
it was
current to
only
get him.
and it was only about an amp.
Well,
So
20 milliamps will kill you, won't it?
yes, but
But
I
it's
think he
it's
was.
more likely at that to go because he's well earth. It's more likely to go across the surface of the skin because that's low resistance than to go through you.
Oh, that's interesting.
So he will have a really bad burn on his hand where the arc hit him, and he'll have a really bad burn on the other hand where the arc left him.
Yep. So
Right.
one was on a finger. One basically nearly took the end of his finger off, and the other left sort of several layers of his palm skin on the door.
God,
Yay.
poor guy. Bloody hell.
Well,
Jesus.
I mean, the capacitors my mate got, they were from London Underground.
2.5 kV is not going to jump very far. He must have touched it.
Yeah. He claims he did. I mean, even 12 kV isn't going to jump that far. But the thing was that it then went into a pulse forming network at 12,000 volts, which works exactly the same way as the ignition coil pack on a car ignition system works. But of course, we're not starting from 12 volts.
Yeah.
We're starting from 12,000.
Jesus Christ.
By the time it had gone through the pulse transformer and actually got to the point where it needed to be used, from memory, it was 120,000. Well, it was minus 120,000 volts at something around 100 amps.
Ouch.
I'm amazed he survived this.
Well, that's at the far end of the system that you can't get to because it's in a cabinet that's got 2-inch thick lead walls, roof and door. Because the device that you're firing it into is essentially a almost 2-meter long linear accelerator, accelerating electrons.
Oh, Alan, sorry to change the subject completely. Do you know anything about this storm shadow thing and how good it is? Brief change. Okay, forget it.
I was trying to think. That's
the cruise missile that the Ukrainians have been given by us. I was just wondering if you had any experience of it with all your aeroplane type thing. Okay, all right.
No. Yeah, you have to remember, I spent 9 years in the Royal Air Force. In my 9 years in the Royal Air Force, I spent 3.5 minutes total in an aircraft on duty.
Okay.
Oh, it's Anglo-French.
It is indeed, yeah. But I just wondered if I don't know whether Alan was familiar with missiles or anything. That sort of lark. Anyway, I don't want to change the subject.
I can tell you the targeting system was probably based on Raquel Milgo.
Based on what, sorry?
Raquel Milgo. It was an old defence contract. So most of the British missiles use their targeting and gyroscopic systems.
Yeah, I think it has got an inertial guiding system on it. I think that part of it might have been French actually. Certainly some of the fundamental underlying bits of that scalp.
Then that'd be Matra or Mantra.
Okay. Anyway, I don't want to change this. Don't want to come to. Well, I'm quite happy to talk about Ukraine, but I don't want to change. Yeah. Okay. Yes. So yes. Electricity is very dangerous. Yes. High voltage. Yes. 20 milliamps will kill you. And I still don't. I'll read up on this capacitor thing. That just absolutely amazes me. They can just charge up, sitting there doing nothing. I'll read up on that.
Rumpers, I'll tell you now, the most painful electric shock I ever had was from 50 volts
Right.
because it was able because it was on a system that was driving lots and lots of relays. So it was able to sink and
Deliver
push
lots of current
lots
to
of
you.
current.
Yeah.
It's not the voltage that'll kill you.
Yeah, that's right. It's the 20 milliamps of current. But the question is that you need a certain amount of voltage to get it going through you. But once it's going, it's the current that actually does the damage.
Yeah. Oh, and grabbing a distributor to adjust the dynamic timing of an engine when there was no insulator boot on the center conductor to the distributor was also a very bad idea.
Yeah, distributors are quite painful. My father once made me hold when he's trying to fix the car to see whether the distributor's working properly. I was having to hold it, and I've been given a spark periodically by it. And I didn't like that very much. I don't know why. He was.
I always wanted to see if you could turn an electric fence from AC to DC and stick sheep to it.
Do what? Sorry. Stick sheep. What did you say?
Yeah, it's the
Stick
classic.
sheep.
Yeah, you don't pee on an electrified fence. You don't pee on a lawnmower.
So electric fences work off a very slow pulse AC.
Right.
You can actually, if you go to if you can hear an electric, this is not around a military base type of electric fence. This is the type of wire electric fence they used to keep farm animals, and you can literally hear it go tick, 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 tick through the wire.
Yeah.
And I always wondered if you turned it from AC to DC, could you stick sheep to it?
Stick sheep to it.
Stick the sheep to it.
As in kill them?
No, just basically freeze them.
Right.
You didn't grow up on a farm, did you, Rumpus?
I do. I was familiar with electric fences. I did used to play when I was well. I haven't experienced doing electric fence recently, but yes, I do. I have prodded them in my childhood to find out what they're on about. They are. Yes, they are.
No, what you do is you grab someone's nose and you grab the electric fence, and then they get the charge straight through the nose. You don't feel anything.
I didn't know that one. Oh, that's good. I must try that with my girlfriend. Oops. Yes, that probably wouldn't be too.
Yeah, that's one of those classroom experiments where they get 4 or 5 people in a row holding hands, and then he ramps them up on a Wimhurst generator, and the whole thing is whichever person lets go, even mid chain of the people, that's where the spark happens. That's the only place. You don't feel the current, you feel the spark. So if Amy and Sandy let go of each other's hand, they get the sparks. Nobody else does.
Amazing. Yes. So of course, these people don't know anything about electricity, aren't they? All these flat earthers. They don't have an expertise in anything, do they? Actually, there's no subject on which they actually know anything about.
They've got expertise in bullshit.
Yes, you don't. You can't take an exam for that, though, can you? At least not that I'm aware of.
I think it's called a political degree.
Right, yeah, perhaps. Or PP at Oxford, you mean?
Yeah.
Yeah. I mean,
it's the same way. I've been asking the same question now on and off for about sort of a year and a half, 2 years. And it's a really, really simple one. And it's got me kicked out of more flat earth servers than anything else. And that's, do you have measurements showing that topography or topology deviates from a flat plane? And if so, can I see the data, the tools that have been used, and the methodology applied?
Well, presumably they wouldn't want to get a result that shows it deviates from a flat plane. Sorry, I'm a bit confused by the question, because you're asking them that it does deviate, and they don't want it to deviate from a flat plane.
No, because obviously topology is the mountains, the valleys.
Do you mean topography? I think you mean topography.
That's probably topography is actually a better word.
Yeah, definitely better word.
And I mean topography. And that is just so funny.
Well, I mean, just ask them simply, can they please give me a map that actually works. So, for instance, that has the distances between places in Australia and South America that actually agree with the reality. I mean, that's just, or as Farmer's Boy's classic is, can you please explain how the sun sunrise and sunset works? And given the fact that you can see half the sun at one point and not half, therefore it's not in the distance, it's not gone away so far. You can see half of it and not the other half. So there's something in the way.
You can be even meaner at that. So obviously, maps are based on a globe using the Haversine formula, because obviously lines of longitude converge at the North and South Pole. Can you show me distances in the Southern Hemisphere on a standard map that are wrong?
Yeah. And of course, I think Whitsitt's classic thing is that the globe model is from a flat Earth model that's been transformed into a globe, isn't it? I think that's his line. It starts off as a flat Earth thing and then is transformed into a globe shape. Is how I think.
Of course, but what about I don't know, celestial poles, South celestial pole?
Yeah, indeed.
How is
yeah,
that possible? Yeah.
Exactly. Yeah. How do you have this axis? Yes, because on a flat Earth, assuming it's sort of planar, then you can only have one point of rotation you can see, because the other one would be underneath you. And we can see both of them at the same time if you're at the equator. How's that? How does that happen? And of course, things like the angle to Polaris. I mean, there's some sunrise and sunset's a pretty good one actually. It's pretty difficult to just that simple personal.
Well, I grew up on the East Coast, and and I love the moonrise.
And so you could see over water.
Every night, pretty much. Well, let me rephrase that. Every night that it was clear, but considering East Anglia has some of the lowest rainfall in the UK, that was more nights than most of the rest of you.
Right. And John Rapp says in the chat that Gary Wybenga, I calls him Why Bother, explains it with his rubber diagram. Yeah, but that rubber diagram, I don't think is relevant to this, John Rapp, because his diagram was that if you were at the base of an object, it would actually, its angular size would get. I don't think he was trying to explain why the. I think that was another issue. I think John Rapp.
Oh, just interesting side topic subject. Have you seen some of the stuff they've been releasing from Turkey, where they've now found a graveyard, a Neolithic graveyard that is a good 4,000 years older than places like Göbekli Tepe?
I have heard of it. I haven't read up on it. So
really, really interesting. I'm trying to remember the name of it, but it escapes me this time.
So
16 and a half, 17,000.
Wow.
Oh yeah.
Because
pushing them boundaries.
Yes, I thought 10,000 BC was the oldest sort of record we have of civilization. Right.
Well, no, the oldest record we have of civilization. Yeah, monumental architecture.
Right.
Old tool use we've got going back well over 150,000 years plus.
Yes, that's true. Yeah, indeed. Yeah. Of course.
But monumental architecture is what we're talking about here.
Right, gotcha.
And then civilization, you require hierarchy, specialization, writing, monumental architecture.
What?
As a
they
minimum.
think they had right? So they
No. That's the classification of what counts as a civilization under sort of standard terms.
Right, so this is not a civilization then?
No, because civilization requires the writing component.
Exactly,
and,
yes,
yeah.
Right.
So that's why we sort of say the earliest civilization that we know of to date is probably the Sumerians.
Right, yeah, indeed. Okay, yeah, I'd agree with that. Right, that was my understanding, yeah. And then that was, what was that, 4,500, 5,000 BC?
5,000, yeah. Well, the earlier 3.5 to 4,000 is where we start getting sort of trading chits and that kind of stuff. And by about 3,500 BC, we've got a full writing system.
Is linear A or linear B back then? Was that?
So linear A is from Greece. That's a bit later. And no, it's linear A from Crete and linear B from Greece. One we've decoded, one we've actually deciphered, and one we haven't. And I think it's linear. Yeah, I think it's linear A that we haven't deciphered.
Okay, so what's the thing in
Cuneiform.
Say again.
Cuneiform.
Cuneiform, do you mean?
Yeah, cuneiform.
Are you pronouncing the word I'm saying just differently, or it's the same thing?
Yes, same word, different pronunciation.
Why are you pronouncing it not as cuneiform?
Because most of the people who are Assyriologists pronounce it as cuneiform, including Irvin Finkelstein, who I have a huge respect for.
I've
So
met that
he's-
guy. But yes, I had a chat. I had a chat with him.
You
got his book and
bastard!
everything. Yeah, been there, chatted to him, got his signature on a book, which is in the corner of my room over there.
Oh, I hate you. Some of the writings that he's done have just been and plus he's a very entertaining speaker as well.
He is, yes. I think he does overdo it sometimes. Yes, I've got his book all about the Genesis and the
that's where he's talking about the coracles.
Yes.
Yes, I know the book you speak of.
And he got terribly excited about some guy turned up at the British Museum with a tablet, and it turned out to have the classic words of the Genesis, whatever it is, the first paragraph or something. Genesis,
and let me paraphrase it for you. And like all things that come to the British Museum and leave, eventually they're bound to return.
Indeed, because it then disappeared. This guy then disappeared. So he came along, turned this thing, sent everybody bonkers with it, and he disappeared for 10 years and then came back again with this absolutely crucial tablet with cuneiform on it. And I can't cope with your pronunciation. And then
Cuneiform. We'll go with cuneiform.
Finkel then translated it, and it was so it demonstrated that the phrase in the beginning there was the Genesis, the ark. The Ark story, he recognized that, and then it was clearly, therefore, the Bible appropriated this story from Sumerian culture that was 1,000 years earlier than or 2,000 years before, and it was sort of myth that entered from the Sumerians, and he had the first record of this tablet from where it originated from. It's amazing.
One of the other things I remember from that book, it's years since I've read that. Was when he was talking about the dimensions of the coracle, and I forget the unit of measurement that they use there. It's like the strad or the stud or something like that. It begins with S.
I can't remember it.
And he got a mathematician to come and work out how much rope was needed.
Yes.
And it was something like 503 kilometers.
Was it? I don't remember being that long, because it was quite a modest coracle in the end, in the thing that he described in the tablet.
I will try and find the quote, but yeah, I tend to have.
I don't know if people realise this, but he found this the dimension for the first time. The dimensions of the ark were mentioned in this tablet, and it equated to a boat or a coracle that was about 50 meters in diameter, I think, or not even that. And this rope was wrapped round to form the edges, I think it formed the bottom as well, and then they used it like it became a cylinder, and
then they put wooden ribs in it to
yes,
stress
that's
it out.
right. Yes, so it seems an odd construction, but anyway, that's but I don't remember it ever being 500
Oh, he
kilometers.
died! No fucking way.
Right, so you're never going to see him. Yes, he was a bit old when I saw him. I must admit that was about 10 years ago, 8 years ago. I've got his signature though in his book.
Oh, it might be a different one actually.
What? There are two Irving ankles. Is it Irving? Irving? Is it Finkel? Irving Finkel, yes.
Great name too.
Yes, 2014. I think that's when he wrote the book that I've got. How old is Irving Finkel? Oh, he's still alive. 71 years.
About 70.
Yeah, don't worry, it was a wrong one. It was one in America.
Right. Okay. Yes. Anyway, so yes, very interesting Bloody hell, I've forgotten your original
The
name
length
now.
of palm rope required for such a large boat would, says Finkel, from stretch from London to Edinburgh. I have
You're
got.
talking about
As I said,
Gilgamesh at the moment.
at Unapishta.
Unapishta, yeah, but it's the Epic of Gilgamesh, yeah.
Yeah, it's in the Epic of Gilgamesh. Poor old Gilgamesh found the secret into immortality, and it got nicked by a snake.
That's the way these myths go, I'm afraid.
Stanchions, that was the measurement used. Sorry.
Right. You're breaking up, S1. Or broken, in fact.
This is getting a hard time about stuff.
You're roboting
It's
quite
not the best time
badly.
to bring it up.
Well, we're only getting half.
I do robot.
Well, we're only getting the middle of your sentence.
I'm sorry about that.
Oh,
yeah,
no, not that
it seems
one.
to happen every time I join the Discord.
That's
Have
okay
you
now.
got push to talk on?
I beg your pardon?
Have you got push to talk on?
Unfortunately not, otherwise I'd use it. No, I might just drop out.
No,
you're good now.
You're fine
You're good now.
Oh, right.
Yeah,
I've got a good connection.
perfectly.
Yeah, so the thing about capacitors, the reason I joined was the discussion about 10 minutes ago, and it took me a while to get in, and Lee managed to get me in by giving me all the right credentials.
Yeah, go ahead.
I work with high voltage and large capacitance capacitors, and really they don't charge from air. It's just that they take a while to discharge. So you charge it up and you walk away, and it's still got quite a large charge on it. You can then discharge it through a resistor or whatever safely, but then there's still, especially if it's an electrolytic capacitor, it takes a while for the equilibrium to drop to zero as all of the ions drift around.
Yeah, right. That makes sense.
So it isn't that you just leave them in the open air and they just suck ions out of nowhere. It's that they've still got some time to equilibrate their internal chemistry.
Gotcha.
And it was really infuriating to hear two people who have some sort of electronics claim and Rumpus, who's got none, and Rumpus was saying, that sounds like bollocks to me, and it was bollocks. So, that's why I was.
I'll take it. It could be an urban myth, but I was always told
what you've fallen for is an urban myth. When I also have worked this sort of not high energy lasers, but lasers that take like 40 kilowatts or something to run. Sorry, 40 amps to run on 3-phase. And those things have got like Coke can capacitors that are a few millifarads that will run at 400 volts. And you don't get anywhere near one of those. The important thing is with a capacitor that they will discharge instantly if they've got low internal resistance. I mean, Alan was talking about the currents and voltages. Yeah, you put 400 volts into a capacitor, and if it's got a reasonable capacitance, it can discharge those 400 volts immediately that it gets to the circuit. Once it's charged, if it's got no internal resistance, there's nothing that graduates the amps. So it'll give you kiloamps for about a microsecond. You get this huge amount. If you've got a low resistance, it will just produce an incredible amount of amps. But as someone mentioned, the 20 milliamps. That will kill you. That's 20 milliamps across your heart. And if you've got like 4 kilovolts across your hands, then you might get that might force 20 milliamps across your heart. But
there's a lot of resistance between your skin and your heart.
Yeah. If you've got,
is it 20 milliamps for instantaneously, or does it need 20 milliamps for say a millisecond or something?
I have no data on that. I've got no idea.
But Well, no, I mean, when you put a pulse across the heart, it causes an arrhythmia, and that's what fucks you up.
Yes.
Well,
And it can literally
interestingly,
stop. Yeah.
interestingly, that's how defibrillators work.
Yeah.
So you get an arrhythmia that is sort of tachycardic arrhythmia. You're fibrillating. You've got this sort of really high frequency thing that stops your muscles from working properly. And what defibrillators do is they give you a pretty solid, not very high frequency pulse, across your heart that stops it. And it stops it because it's not a high frequency thing. It just goes, whoosh, and your heart goes into a like locked up state, and it stops beating. And then, because it's got an internal pacemaker that works at the right frequency, that pacemaker kicks in. When I say pacemaker, I mean it's like the Purkinje tissue, and it's integral nervous rhythm.
So S1R, just I put in a quote, and this is from epower.com. So that says capacitors, as well as other capacitors used for the purpose of the circuit, can store a charge for a long time, even when they've been disconnected from the circuit or after the power is disconnected from the device. High voltage capacitors can accumulate charge even if they've never been used due to electrostatic charge buildup. As such, they pose an electrical shock hazard. Because of this, it's necessary to discharge capacitors before handling them to prevent injury. High voltage and high energy capacitors should be stored with their terminals shorted to prevent charge buildup over time. That's why I think what I think.
What I missed is where you got the reference from. I'm not looking at the phone. It's taken me like 15 minutes to get into this. I don't want to break out of this and look at my.
Well, could it be that
tell me what the source is?
eepower.com.
What's eepower?
Just a reference site.
A reference site for what?
Electrical engineers.
What is it? Right. So eepower is.
Yeah. What I've done is I've just sent you the link as a direct message. I've sent you a friend request as well. But you don't have to look at it now. Don't worry about it now. It's not. I'm not contesting your point, because I don't know enough to know if this is urban myth or not. And I have found a lot. And I found a lot of stuff that appears in sites like this that have come up as urban myth. If you're working in the industry, and I don't, I'm going to respect your point of view.
Yeah.
Well, could it be the electrical material inherently has a charge associated with it when it's made?
They can have charge inherently in them when they're made. Like we have charge. We walk around and we generate like 20,000 volts as we walk around. And if we touch the wrong thing, we can kill it. If it's like a CMOS, a complementary metal oxide semiconductor, then we'll kill it.
I used to charge up the cat. I had a cat that I used to rub up on the carpet, and eventually, and then turn the nose, and you get a spark across the nose of my finger.
Yeah, luckily that will not kill a cat. But it will kill something like a laser diode. So you've got a high power laser diode. The reason the high power is that they've got very low resistance, and any voltage that you put on them will just run through them. And if you've got a 20 kilovolt charge on you, and you touch it, then that will discharge instantly through the sort of 0 ohms that the laser's got, the diode's got, and it'll make it massively overproduce light, and the light will destroy that laser diode. And there are lots of misconceptions about what a shock is and how it goes, and to hear it in a thing where people are debunking other people's lack of knowledge is kind of heartbreaking in a way. That people will sort of say, well, I've got this idea and I'm going to stick this in, I don't want to find out any more. And then put it through as truth to lots of people who then take it as truth because they say it so assertively.
Yeah, no, I agree with that. I mean, and it's why, I think it's one of the big differences if you've been in sort of like the sort of the flat earthy conspiracy kind of world, is I think most people who want to be in that world deal with absolutes. And I think over on the more rational side of the fence, we always have a certain amount of doubt.
We do, but we would enjoy being absolute. Everyone enjoys knowing what it is. I mean, like, as people were saying about Bev earlier, you know, Bev seemingly has settled on, in my view, Bev settled on a bunch of truths that you can kind of grasp and extrapolates, and then decides that these other things, whatever they're based on, I don't need to know, because I've got a core truth that I believe. I don't need to know anymore. And I hate it when people do get into that mode, and this conversation seems to be going into that mode about capacitance earlier. So,
Yeah. I was going off stuff that we were taught when I went through the RAF trade training school in the mid 1980s.
Yeah, I'm not jumping in on everyone. It's just the way it was going. I wanted to come into the conversation. It was a while ago. You know, I'm not. I mean, I can't remember if you said anything particularly, Alan, that I disagreed with. It's just.
Well, I mean, I'm always open to discussing it and learning new stuff, because they may. I mean, yeah, they may well have just generalized stuff, and some stuff was just general. You know, some stuff like that would have just been generalized. Don't do this because it will hurt, because, and then it.
Okay. I mean, there's a lot of health and safety. Don't do this because it will hurt you, rather than this is why it will hurt you, and what brings that about, involved in just about any trading, really. So yeah.
Yeah.
Usually things are stipulated with what, like how they'll hurt you. It'll say, do not use this chemical, will cause eye irritation. You know, like it tells you like how it's going to hurt you too. A lot of the time,
quite.
May cause cancer.
I mean, I was always taught with high energy, high voltage capacitors, you had short terminals because otherwise they'll charge. I was taught that as well, which is why I find it a bit weird. Now, why, which was the point that I didn't try and comment on, I thought, well, it could be this, it could be that, but I didn't really know, and I wasn't trying to assert it as fact.
Yeah. Well,
but there's obviously a reason why you're supposed to store them like that. And as I say, I've seen several references, one of which I managed to pull up today, which say that if you don't, this is to prevent charge build-up over time.
But it's more charge leakage. It's the fact that they can actually store it and they don't give it all out. So
and why would it build charge? So why would it build charge? Why would they say it builds charge over time?
It's more that it stores charge and it doesn't immediately give out. Because with an electrolytic, particularly capacitor, what happens is, you get ions move. And the ions don't move instantly, and nor do electrons, obviously. So you stick a resistor over it, because if you put a spanner across it, it will vaporize naturally. So you put a resistor across it, so it discharges rather than in a microsecond, it will discharge in a second.
Yeah.
Not only discharge to a certain amount, but then you get something equivalent to remnants in a
have you ever seen something like? I mean, as I say, one of my mates did it once.
Did what?
And it was basically shorted a spanner over a very large capacity capacitor. And it wasn't just the fact that it vaporized; it was the sound that it made. That's probably the thing I remember most.
It's like have you ever dropped a spanner across your battery in a car?
Yeah,
it'll do a very similar thing. It goes really quite quickly gone. But the thing is that, like with a battery, you can short circuit it with because electrolytic capacitors are very much like a car battery. It's an electrochemical process. It's got reaction rates. There are laws governing how quickly those things can happen. So although you get a seemingly instant discharge to zero, it's not an instant discharge to zero. It's an instant discharge to zero for now. When you remove the load, you take if you vaporize, spanner disappears, then you get the same sort of effect as you get with an alkaline battery, where it appears to be totally discharged. You leave it stored for a bit, and then suddenly it gets back to the voltage it was at. And it's not suddenly, gradually it does, because the chemicals all sort of move around because they've got time to diffuse. And what happens then is that you've got, instead of 10 kilovolts or 1 volt, you get a fraction of that restored when there's no load on it anymore. But it's not dragging energy out of the air from nowhere. What it is the chemicals reaching equilibrium within them. You know, you just get this diffusion of electrolyte.
Yeah, I think we got that.
Which restores the voltage, and you've got much less capacity than you had initially, capacitance than you had initially. But you can still get a fucking shock off it, so you just don't do it. But the explanation that you're coming up with, where it's just sucking stuff out of the air, it's not. It's just a gradual chemical discharge within the thing that is restoring the voltage across its poles.
Yeah, I think we've got that next one. Yeah, I think we picked that up some time ago, and yes, I think it makes sense. As you said, there's a diffusion process that's got to go on in a potential in an electrical field.
I could have wrote that a while ago, but your man, I don't know who's. I know your voice, Rumpus, but I don't know who I was talking to. I know it's been Alan, but I don't.
No,
yeah,
just now, the one who's sent me things.
Yeah, Foolish Decisions. He's I've forgotten his original bloody name now. What's your original name, Foolish? You keep on changing it. Sorry?
Druss.
Druss, that's it. Thank you. Druss the Legend. Yes, thank you. keep on trying to confuse me. Yeah. So Druss. Yeah. I mean, Druss is not disagreeing with you, I don't think. He's saying he's got a source that he doesn't understand. But yes, I mean, we understand the principles you're talking about, where there's a diffusion process that's got to go on. So no one's disputing that. I think. So we're agreeing with this. So thank you very much. That's very informative.
No, because I think he read it out. He read it out as the content of it, and also gave me a reference which I haven't read. But he seemed to think that was a valid thing that would be useful to discuss. So I was just discussing it. That's why I said what I just said.
Yeah.
I wasn't saying it to repeat myself. I was saying it because it seems to be embedded in what he said.
There is one thing I have seen that wasn't an electrolytic capacitor, but it was a device that did seem to be able to build its own charge over a period of time, and that was somebody putting themselves between the cathode and anode of a cathode ray tube.
Right. You can make your own capacitor.
Doesn't sound like a good place to be.
Yeah, this was one that they literally. This was a new one that they were getting out of the box to put into the radar display, and it had it. Okay, it was supposed to have been discharged when it was packed.
Because everyone does that.
Don't ever believe that with a CRT. Trust me. Don't ever believe that.
No.
CRTs are really, really good capacitors. They don't have a lot of capacitance. Might only be a few picofarads, but it's enough to knock.
There are several kilovolts, right?
It'll knock you on your ass.
I'm fairly certain that on an NEC monitor, I think there were microfarad capacitors, if I remember rightly.
Yeah.
Yeah.
But
I'm just talking about the CRT tube itself.
Yeah.
Yeah, that is it's a few nanofarads, but it's a few kilovolts too.
Oh yeah.
Yeah.
And that's
Yeah,
the thing that gets you.
And they do definitely seem to be able to draw charge from somewhere, even when they're not connected.
Well, it depends if they're discharged before the fact, because it would be in fact in fantastic isolation. You know, like being electrically insulated and shock insulated with foam. You know, they wouldn't have had a chance to discharge much, Alan. You know,
Yeah.
that is one that you might have to look into the absolute data of.
Yeah. I mean,
Yeah. What happened to the guy? Did he get a shock, or did he get his fingers taken off, or
he jumped a lot.
well, yeah. You know, so
Fortunately, the tube. Fortunately, he wasn't holding the tube in a way that when he jumped, he dropped it and it smashed. So there was at least that. He was in the act of trying to pick it up when it bit him.
There's some proper cost reduction there. The tube survived.
You know, and of course they're forever on telling you about how delicate these things can be and how bad it is if you crack the neck. When you in fact, when we did a tube replacement into the console, we used to have to wear this thick leather apron because they said if you cracked the neck and it broke in the right way, the implosion, the implosion could send the electron gun through the screen into your chest,
right,
and bring lots of shards of glass at you.
Yeah.
And of course,
it's more if you stood behind it, I think. But
the big leather gauntlets that you had to wear while you were putting the thing in
make it very clumsy. Yeah.
Yeah, and you kind of you get the tube so far in, and then you realise that actually because you've got the leather sticking off the ends of your fingers, you've slipped your fingers round, and now the tube is wedged between the leather of is wedging the leather between the tube and the frame, and then you can't pull your fingers out because as you pull your hands out, it just leaves the bloody gloves behind, doesn't it? The gauntlets.
Quite. Well, my worst electrical, the person I know who said the worst electrical disaster occurred to him was an engineer I used to have on one of the machines I worked on for my service. But he started off doing electron microscopy. Well, he works as an electron microscope technician, and they got quite high current and very high voltage rails.
Mm-hmm.
And he was working in the UK, but working for a German company. And according to him, when I asked him what happened to his fingers, he said, "Well, what I was doing was, I'd been working for this electron microscope company. I went to work for this other one, and they had a different ground rail and high voltage rail layout. And I was holding a spanner. I'd been for a plate for lunch. I was holding a spanner, and I put my hand down to position myself properly. And essentially, his spanner was on one of the rails, and his hand was on the other, and he had his fingers blown off.
Yeah.
He got sacked as well because they're not want you to hang around. I think he got some sort of payoff. Then he worked in the industry I do, which involved the lasers rather than the really high voltages. But there are lots of stories that people tell that do spread around, and some of them just don't add up.
Yeah.
The one for my guy does, because I've saw his fingers. But if someone says, "Oh, I got a shock off something," Was it just static? Was he really sensitive to static when he got it out of the insulated box? When he got his CRT out, he got a bit of a jolt off it. Was it because it was in foam packaging and lots of sort of static built up as he took it out? Could it be that, Alan?
Yeah, I mean, all I'm saying is having seen somebody get a bugger that hurt off a tube that came out of the packaging,
Yeah.
that was not supposed to have charge on it.
Yeah.
It makes you be careful of that sort of stuff, doesn't it? Anyway, you just get kind of
Well, it does, but it is different from like half a joule coming out of a capacitor, if you know what I mean.
yeah. Oh, it's yeah. Sorry, I'm starting to get a little bit tired now, which is why my brain is giving these non sequiturs from me every now and again.
I'm just tired of me being hard to listen to. Sorry about that.
No, it's 23:16, isn't it? Here in the UK. It's it's starting to get
It must
towards
be
going
around
to
there,
bed.
yeah.
It's
Yeah.
starting to it's getting towards going to bedtime.
Well, I'm getting ready to end this stream, I think. We've had it going for 3 hours and 15 minutes, 16 minutes now.
Ooh.
So say goodbye to everybody out in YouTube land. Thanks for tuning in, folks. We had some fun.
Yeah, it was good to speak to you all.
Yeah.
Yeah, good to hear from
It's
you, Legend.
nice to get somebody new.
I've been here before, but not so well spoken.
Yeah, Petey, take care. Thanks, man. So with that, anybody got anything you want to say to YouTube other than good night?
No, definitely good night.
That'll do it. We'll see you guys later.